TJump, we're here to talk about flat Earth, I think. Yeah, it's good enough for me. Oh, sorry to interrupt. I'm having a tech issue. I'm gonna have to rejoin 1 second. Damn it, that's not what I wanted. Mm. All right, let's see if I can fix this shit. All right. Sound options. Should be this guy. Well, the audio issue I'm having is that the audience can't hear you. No, I am, but even though I'm screen sharing and I have it selected with. Well, that doesn't give me any money. That would. Oh, that would give me no money though. So that would just give me a minute. I can just copy it over later. But I do want to go settings, video, audio, output. Um, hmm. Audio. Audio. Hmm.
What can be
Testing,
shown,
testing.
what can be
Hmm.
tested, what can be measured, what can be repeated, and that's all. I have um, no preconceptions, or had no preconceptions about something like God, for instance. I just see no evidence for it, and have seen nothing to indicate that we're being lied to, whether that's by Freemasons, Jesuits, or anybody else.
Yeah, well, one of the things that we're going to be pointing out today is
I was going to say, of course, the Vatican has its own, or I assume they still did. They certainly had their own astronomer, and wasn't it through them that the idea of the Big Bang was it? I've forgotten the guy's name. Was it
yeah,
Lemaitre?
they made up the Big Bang. The Vatican
Well,
did. Jesuit
a
priest.
guy who happened to be that came up with the thought. But since then, it's been all the evidence continues to point towards that. If you can come up with some evidence that shows that cannot be the case, then that theory would have to get thrown out. That's science.
Oh, that's a perfect setup. That's a perfect setup. So
Good.
when we do get to screen sharing, um, we're going to start off with debunking heliocentrism. I've got a
Oh.
we're going to show you that we can. So are we good now?
I figured it out. It's the Zoom thing. I need to select the output audio to a different one than it was going through the wrong audio output. All right. I believe that should have fixed it. Can you guys talk for a minute? I can't hear you at all. Oh, wait, what?
Side, the people in your chat becoming involved. In this side, we're not going to be paying attention to that because we're focusing on the conference call that we're in here. So we wanted to promote getting as many questions as the information that Jason's going to be presenting. I've got some information, but this is mostly to show what Jason had prepared. Do you have my sound? You sound good, brother. Yeah, I want to finish the statement. But if you can't get it to work, we're going to have to wait. Thank you, everyone, for tuning in on the Awake Souls channel. It's back from the two-strike deficit, and it's now available for us to use without them taking it, right? Like they took my channel in June, July, they took it.
Well, this wouldn't have known any difference until I would have gone live, and the people in the audience would have said, "Yeah, it's just because it's Zoom. It's a Zoom issue." This is why I don't use Zoom ever for any reason. No.
Arrow up beside the mic, and then you've got different settings on this, and you need to probably
No, I'm like the output software is a screen capture. So the output software should be the desktop. It should just pick up desktop audio. There's no, it doesn't like what? No, like what? Which arrow? The mic arrow? Yep. Headphones, Rocka Juke. My headphones. Yep. Desktop audio. So it just picks up anything that goes to my desktop. Everyone gets muted and I can't hear anything.
Because that's probably the connection right there.
What? Well, there isn't like a desktop option. You have headphones, you have the microphone, which would not do anything, has the audio driver, which is the desktop, and has the TV, which is the desktop. And either of those would be desktop. But yeah, it's just not sending audio from Zoom to my desktop. Like if I not only do I not, the audio doesn't go to the audience, but it also doesn't come through my speakers, which is weird. Yeah, that might work. I'll try that. I have the Zoom app thing downloaded, and I use Microsoft Edge on the other one. I could possibly try that. All right, I'll restart. I don't get any money. Like all I care about is money. So that's the only thing I care about. Well, I've had this problem with Zoom before. It's just Zoom is garbage. That I believe is the fundamental issue. But yeah, I'll restart and see if I can fix it. No, live. You get super chats are the primary source of revenue. Give you my stream key. All right. All right, I will restart. Give me 1 minute.
Created by Kabbalistic mystics to give people a creation to worship instead of the true creator to be found within your heart. Back to you, Jay. That's my opener.
I have a YouTube channel titled Automated Judeo-Christian. Just firstly, how long have I got for my opener?
I don't care. Go.
Okay,
here, we're actually going to have somebody to respond to these, and I'm excited about that. The second thing is flat earth proofs. We're going to be focusing on rivers. I've got a video about this. The third's how perspective works on a flat plane and not a globe. The fourth is materialism and atomism is Kabbalism, just like heliocentrism. The fifth, the origin of heliocentrism, we're going to be going over. Six, clouds behind the sun. This is a big one. I've stated for a long time that this is the number one way for a person to be able to prove to yourself that you are in a virtual reality. Ninth is sky shadows pointing to the sun's location in the circle of sight. The 10th is heliocentrism is Kabbalah. All right. The 11th is planes flying through the sun debunks overexposure being the explanation for clouds behind the sun. The 12th is the green flash and water liftoffs that we see when filming the sun, what we actually witness. And the 13th is going to be how far can we see? So we're going to be showing the limits of sight and how things work on a flat plane today.
Hey, I might even have 13 memes to add into the content too. Who knew Friday the 13th could be such a fun day? I think T-Jump's back.
How are you doing, T-Jump?
Good. Can you guys hear me now? And the audio, people in the audience can hear you now, so that's working.
Oh, they can? Should I do the intro again?
Sure, go for it. That's fine with me.
Yeah, okay, let me do it again real quick. I had a good test through to go through it. So, hi, I want to introduce myself. Hey, you know what? Actually, Mr. Sensible, why don't you go first, please?
Intro again.
Rude. Yes.
Okay, I'm an ordinary guy, not a scientist. I follow the science. On YouTube, my life has mainly been debunking or trying to debunk flat Earth with a little bit of humor and a little bit of science. And I think that's about it in a nutshell.
You're muted.
That's okay. I should be unmuted. That's great. I like how you said you follow the science because that's what we're trying to ask people today. So, hey, nice to meet all you on T-Jump side and Mr. Sensible's side. I am Ron, the creator of the YouTube channel, The Limitless. I'm excited to be here present right now for this discussion about reality, the one that we live in. So unfortunately, we will not be sharing the quote, straw man, fake, Freemasonic, UN, pressurized pizza dome that's flying in outer space with its never setting, shrinking sun traveling over infinite ponds. We're not going to have any of that. If you'd like to see any of that coverage, check us out at our link in our chat on Telegram at Reality Check. But what we do want to try to attempt today is to show you how our realm actually works with repeatable, measurable observations that we can all actually go out and do ourselves. I know for sure already that you're going to be reality deniers. It's okay, I do. But what I ask of you is that you put aside your pre-programmed indoctrination and allow the evidence to speak for itself today. And lastly, heliocentrism was created by Kabbalistic mystics to give people a creation to worship instead of the creator itself, who is inside of you. And that's it for my intro. Thank you guys for having me on.
That's great. So did you catch the 13 points that I plan on covering today, T-Jump?
Did I do what about 13 points?
Did you catch the 13 points? Did you hear that?
I did not know.
Okay. So let's go through the 13 points that we're going to be going through, and I want to find out which ones you guys enjoy the most. But these are, number one, heliocentric debunks that no glober has been able to respond to. All right, that's the first topic. Second one, flat Earth proofs. We're going to have a focus on rivers. Third, how perspective works on a flat plane and not a globe. Fourth, materialism or atomism is Kabbalism. Fifth, the origin of heliocentrism. Sixth, clouds behind the sun. Seventh, the emboss filter. Eighth, planes above the sun and moon. Ninth, sun shadows pointing to the sun's location in the circle of sight. 10th, heliocentrism is Kabbalah. 11th, planes flying through the sun debunks overexposure being the explanation for clouds behind the sun. And 12th, the green flash and water liftoffs that we actually film with cameras like the P1000, P900. And then how far can we actually see? So the limitations of our circle of sight. So these are the topics we want to get into. Is there anything that you want to cover before we start looking at some stuff?
I don't know, Mr. Sensible, what do you think? Do you have a preference?
No, I'm happy just to get stuck straight into it because I'm not sure how much time we're looking at, but I haven't got forever.
Gotcha.
Yeah, anything's fine with me. I don't care.
Like at least 2 hours, I think, right, Jay?
Yeah, well, we'll see what we can get through. Some of this information is going to be really interesting, and we may get stuck in an area for a while. So let's get the screen share going, and
let's see how that goes. But thank you, everybody, for tuning in. Make sure any questions that the audience has on TJumps that you super chat them. I don't know how much you're going to do this, but send them to Zazel chats. And then I want to hopefully have some great interaction with TJumps chat where they come up with good debunks and content and comments about the content that Jason's going to share. And I'm not going to talk over either of you two. If you guys want to interject at any time, just, you know, I just put my hand up sometimes. It's easier to communicate that way. I'm just going to be quiet and allow Jason to present. And I can't wait. I'm really excited to get, you know, a globe earthers or a heliocentric model's perspective on the things that we've been trying to discuss with heliocentrists for years now. So thanks, Jason. If you're ready, I'm going to mute. You haven't screen shared.
Oh,
thanks. Also the sound. Make sure sometimes, because when we go live, sometimes you forget to click that button, right? But anyways, let's go, everybody. Arms up. It's going to be fun.
Do you guys have, was clouds behind the sun one of the options?
It was.
It is.
That would be a good one to start with. That one's fun.
Yeah, it is fun. But what we want to do is establish that heliocentrism has been debunked. So with this video, what I did is it's really just a study of the moon and how the moon debunks heliocentrism, because there's so many different ways to debunk it. But with this one, I got to ask you guys, from heliocentrism, what is your explanation for there not being a lunar eclipse every single month?
Simple. The moon isn't always directly in between the Earth and the sun.
Okay, great. Yeah, so do you know what they call that area? The area that you can't have an eclipse? Right, or the area that you can have an eclipse. So they refer to it as the lunar nodes in heliocentrism, and their lunar nodes are at the equinox. So what we're going to be doing is taking a look at the heliocentric model, their explanation for there not being a lunar eclipse every single month, and see how this works out. So let's check this debunk out.
Number 3. I want to give special attention to heliocentric debunk number 4 because it is the most easily verifiable debunk of heliocentrism in my opinion. Let's focus on the fact that the only time a lunar or solar eclipse could ever take place in heliocentrism is that.
All right, so do you see this here? We've got, this is right from timeanddate.com. This is standard heliocentric graphics here. And what we have here is the March equinox and the fall equinox that are the times that they say are the only times that lunar eclipses can take place.
So hold on, we've got to slow you down here. What you've got is a problem with your pass-through on your audio. So you've got to rewind the video, hit play, and watch on your audio direct link, and make sure you see that red bar coming all the way to the top, because we're getting comments. Can people hear me talking right now? Because my audio is cranked, and I want to make sure that everyone is saying there's no audio. And if there is no audio, Jason has to go in and switch that. It could be also the way that you're screen sharing Zoom, but it should be passing your audio through. I can hear it on my Zoom feed, but I don't think that Zoom, the OBS.
Yeah, I hear the video.
Do you see the OBS bouncing?
Yes.
You do? When I talk, you hear me clearly, because they're saying on the other side of the screen that they don't hear me. I don't understand what's going on with the sounds.
No, it's clearly, I'm getting internal sound on
it's
OBS.
Bouncing up on the OBS. Then it should be good. Maybe everybody's just behind us on the stream.
Let me try boosting it a little bit.
Yeah, sometimes I have to keep mine a little boosted too. I just watch that line and make sure that you know what you're doing. I'm just trying to talk while we get these few things ironed out. Cannot hear Ronnie or the video. That is crazy. I've been talking the whole time. I think TJump and Mr. Sensible can hear me, right?
Yeah, I can hear both you and the video, and the stream, my stream
Once
can
you
hear both
screen
you and the
share,
video.
yeah, there's an issue with the screen share, but if it's showing it bouncing on the OBS screen, it should be good. I don't know why it's not.
Well, and the thing is we don't have to. We don't need the audio and the video, so we can go through it and analyze this.
Yeah, we can just go to the
itself.
Wikipedia for lunar nodes. They have lots of pictures that
Debunk
work
number
too.
4.
Yeah, this is the graphic that you're going to find, right?
No. It might be similar, but the one on Wikipedia makes more sense to me.
But what's the issue? What's the issue with this graphic then?
What's the issue with it? So at the equinoxes, right, this is the only time you can have eclipses of the moon or the sun, right?
And
well,
on the equinoxes, and you still need to boot. You need to boost up your desktop audio. Nobody can hear everybody clearly. You just double click on the desktop.
I did boost it up.
Yeah. Well, I don't. They're still saying that everyone else is quiet. So we're now talking. They can barely hear TJump or Mr. Sensible. I don't understand why they're having this problem. We've tested this 20 times. The equinox report is the question was, why don't we see an eclipse each month? And the answer is because eclipses only take place supposedly in the heliocentric model during the equinox period. That's the answer that you get off Wikipedia, right?
Sure. So if you could just go to the picture on Wikipedia, it explains it pretty clearly. The Wikipedia one shows exactly if the moon is, if the tilt of the moon, since it's on the rotation isn't perfectly perpendicular to the rotation of the Earth around the sun, if the moon is above or below the Earth relative to the sun, then the shadow won't go on the Earth and you won't have an eclipse.
Yeah, that's this graphic that we're looking at right here.
I can't see that at all. It's just, it's like
T-Jump's channel has the good audio, so let's just move on and we'll deal with our end any way possible. As long as his audience is getting the good quality of audio, we're going to just move on, and they could probably hear the screen share volume too. So we can just go forward with the sound, everything the way that it was, Jason. Start again.
Yeah, well,
thank you, David Pack.
We are into this graphic, and here is the debunk of heliocentrism right here. Because the March and fall equinoxes are the only times in heliocentrism that you could have a lunar or solar eclipse. All right, so these graphics where the June solstice and the December solstice is, I'm going to zoom into them in the heliocentric explanation right here of, right, I'm going to focus now on what it says is impossible.
You can play the sound. It works. Great.
Near the June solstice, the model literally makes it impossible for either a lunar or solar eclipse anywhere near these dates. So,
do you guys see and recognize the heliocentric model here? This was your explanation for how there's not a lunar or solar eclipse every month.
Sure.
Right? Right. The moon's too high and the moon is too low.
Sure.
All right. So do you recognize that, Mr. Sensible?
Well, the moon's orbital rotation is at an inclination. So, I mean, obviously there's always a shadow. That shadow is a cone. But if it doesn't intersect with the Earth, you won't get an eclipse. If it does intersect, you will.
All right. But so the heliocentric explanation for why we don't have a lunar or solar eclipse every month is that at the solstices, because of the 5-degree tilt of the moon to the ecliptic plane, right, and the Earth's tilted 23.5 degrees, that puts the moon too high or the moon too low to be eclipsing, correct?
Sure.
Yeah,
what's the argument here?
Yeah,
right,
I don't
what
get
happens
either. We both acknowledge that sometimes the shadow will miss the Earth, then there's no eclipse.
If we look up the dates of projected lunar and solar eclipses, will we get any outside the narrow window of the equinoxes, which are the...
All right, so a big popular eclipse, June 21st. Can anybody tell me what day of the year June 21st is?
No idea, but the
summer
graph
solstice.
you shed doesn't show anything about
summer
months.
solstice.
Quarter of the year past the equinox.
Okay.
This is exactly in the range where heliocentrism says it's too
June
high or
solstice
too low.
isn't anywhere on the picture. There's no solstice part. That's something you added. So that's not in there. So there's the Earth's orbital plane, and then there's the Moon's orbital plane. And when those two align with the sun, you get the eclipses. It doesn't. There's no months. There's no months anywhere on this picture. That doesn't exist on this picture.
Do you recognize this?
Do I recognize this?
This graphic here?
No.
No?
I
Mr.
don't.
Sensible, do you recognize this graphic?
Sorry, what aspect of it? I mean, that's showing the Earth tilted about 23.5 degrees, rotating around, orbiting around the sun.
Yeah, it's heliocentrism, right?
Yeah.
Well,
So
I definitely the sun's in the
arrow
middle
showing?
there.
What's the
so
arrow showing?
the June solstice, right? It's supposed to be, the northern hemisphere is supposed to be tilted towards the sun. The December solstice tilted away. Do you understand where the months line up with the equinoxes and the solstices?
Yes.
Right. TJump was acting like he didn't, like the debunk of this was that this isn't the June solstice, when you're literally using the heliocentric graphics.
But I mean, the moon is constantly orbiting around the Earth. It's cycles within cycles within cycles. You've got rotation of the Earth, orbit of the moon, the orbit of the Earth around the sun. Sometimes those cycles will line up, and sometimes they won't.
No,
Lunar and solar eclipses?
let's go back to this graphic here. All right, the June solstice, the explanation for why we do not have lunar or solar eclipses every single month is that the moon is either too high or too low, making it impossible to have a lunar or solar eclipse at the solstices. Yet when you search for eclipses, list of solar eclipses of the 21st century, the very first
Will
one
we
that
get
they
any
list
outside the narrow window of the equinoxes?
is June 21st.
I never said
Summer
it was
solstice.
impossible. Like that's not a thing. Like the tilt from the moon relative to the sun is like 5 degrees, so it's still possible. Like I never claimed it was impossible. There's no issue here. Like this would not in any way be a problem with the heliocentric model.
No, what's not getting through your head? Because we literally have heliocentrism saying it's impossible right here.
No, there's no point where it says it's impossible there.
It says
It
too
says there's
high
a
or too
5 degree
low.
tilt, and so at the top of that circle, it wouldn't happen for that diagram. That's all it says. It doesn't say anything about it being impossible. It's not in anywhere in the diagram.
All right. Well, let's not
We
belabor
can
the
check.
point
Is
too
it
much.
what is your question?
There's-
Is it possible to have an eclipse during the June solstice? That's your question?
In the heliocentric model.
Yes. Well, I mean, everybody pretty
Although the model demands that they
sources are
happen
gonna
during
be
the
on the heliocentric model.
They just stated that they happen during the equinoxes. The solstices are again
I don't care
another
about the
3 months
equinoxes.
later.
Like, an annual eclipse appears as a partial eclipse over a region of the Earth's thousands of kilometers wide. The eclipse will start only a few hours after the northern solstice, and most of the path will increase across areas with midnight sun. Yes. Solar eclipse June 21st, 2039. So yes, there's no
Yeah. So
heliocentric says yes,
heliocentrism
we can, no problem.
debunked there. Now we've got more.
Well, there's no debunk there. Like our model says, yes, you can have those.
No. Where I'm showing everybody the model literally.
That's a picture. That's a picture. That doesn't say that they're impossible.
That's the
It says
heliocentric model. That is the heliocentric
that's
model.
picture.
Well, it's one snapshot of the
Yeah.
heliocentric model. One
Well,
snapshot.
4 snapshots.
Specifically- Specifically for the reason of explaining why there is not a lunar and solar eclipse every single month.
Right. And you've picked a picture of one example where the picture does not show any shadow. Does that entail that the heliocentric model says that they are impossible? No, it does not say that.
All right, there's more ways to debunk it. Let's go to heliocentric debunk number 3.
2. There is another closely linked debunk of heliocentrism, and that is the direction that the path of totality shows up. The path of totality could only show up on the ground as traveling from east to west, due to the direction of rotation of Earth. Let's zoom in here a little bit and watch. The path of totality of a solar eclipse is a narrow, roughly 70-mile wide band that experiences the sun fully blocked by the moon. With Earth spinning in the direction required for sunrise to be in the east and sunset in the west, we can clearly see that all eclipses must begin in the east and travel west. This is an unarguable
before you go on, I do
point,
want to
and the
comment on one thing. So, like, the original point you made was that lunar eclipses don't happen every month, which is fine.
No, I asked you the explanation for why lunar eclipses
Right,
don't
and
happen
we
every
gave you the
month. And you said
explanation,
it's
and then
too
you
high and
said-
too low.
Wait, and then you said it was impossible for them to happen in this month. Those are two different claims that are completely unrelated. So, like, saying that here's a reason why they don't happen every month, and here's the reason why it's impossible to happen in this particular month. Those are two different claims, and the second claim wasn't being defended there. I don't know, like, why you just deflected on this completely irrelevant topic.
Because I've got so many other debunks for us to get through.
Well, let's cover this one. You're saying that the shadow should travel from east to west because of the direction of rotation of the Earth. But look at that diagram you've got up right now.
Mhm.
Look at the arrows for the orbit of the moon. It's going counterclockwise there. Yeah. So the shadow will move from west to east. The moon is tracking across, or the shadow of the moon is tracking across the Earth comparatively quickly. The Earth is turning slowly. If the Earth was spinning at the sort of speed you're showing in that diagram, then yes, it would appear from east to west. But in reality, the moon and its shadow is crossing the path of the Earth more quickly.
So the amount of time that it takes for the shadow to go across Earth is another one of the heliocentric debunks that we're going to be getting to. Ronnie, what did you?
Let's take it back to the actual debunk here. Is we are actually locating the direction of the eclipse shadow itself. Let's stay on topic.
That's what I was talking about.
Yeah, so here the animation makes it real simple for a person to not get confused, because the Earth is rotating the correct direction here for sunrise in the east and sunset in the west, and the shadow is being cast right here. We do understand that the moon is moving as well in heliocentrism, and we're going to be addressing that. But as far as the direction that the shadow would show up on Earth, you can clearly see that if it's hitting a spot like this
east and travel west,
Earth is rotating.
This is an unarguable.
If you can go back to that animation, what that animation shows is the moon stationary, casting a shadow, and the Earth rotating beneath it. The moon is moving faster. The shadow of the moon is moving faster. What your animation is not showing is a moving shadow. It's just showing a moving Earth. Now, if on the scale you're talking about, because that's hideously out of scale, the moon would be traveling a lot quicker. And so that shadow would be moving from west to east, left from about 10 o'clock till 4 o'clock on your diagram, where that red line is. It'd be going the other way.
Well,
because it's moving quicker.
You've sort of stepped into it, because we're both going to show that the direction that the eclipse starts and the length of duration are both heliocentric debunks as well. So in this case, the Earth spinning like this would cast a shadow that travels from the east to the west, because you can see it on the east coast of Brazil.
Must begin.
Now it's at the west coast.
That is what your animation shows. But the reality, for that animation to be more accurate, that moon needs to be moving.
Well, we'll be getting to that one.
Well, let's just stick with this one right now. So what Mr. Sensible said makes perfect sense. If the moon is moving faster than the Earth, then the rate the moon will move when it hits the shadow is going to be significantly faster than the Earth's rotation in the other direction. And so the speed of the shadow will actually be going from west to east, because the speed of the moon is significantly faster than the rotation of the Earth. And so even though if the Earth was rotating, it wouldn't be rotating fast enough to make the shadow go in the other direction.
So you're pulling model size Earth speed fallacy is your interjection, but that still doesn't debunk the fact that the shadow is traveling in the opposite direction that it would be if the Earth was spinning. Continuing on, Jason, go to your next point.
That literally doesn't make sense. So, like, even if the Earth is spinning,
it makes sense.
No, it doesn't.
Well,
So like if the Earth is
Let's-
spinning, say I have a spinning ball, and then I have an object that's blocking like a shadow because I have a light right there, so there's a shadow here. Now, if I'm spinning, but my hand moves faster, the speed of the shadow will be the speed of my hand minus the opposite rotation of the ball, right? So like if my hand crosses the light,
you're just getting
the speed
ahead
of the
of
shadow
yourself.
will
That's-
be the speed of my hand. And then if
We'll
the
get to the
speed of the Earth is
speeds.
going the opposite direction, it'll be minus, or the same direction, it'll be minus this speed, but it will still be a positive speed from west to east, won't it?
Well, at least you're
it's in the
alluding
video
to-
already.
At least he's sorry, Jason. At least he's
jumping
alluding
ahead.
towards speeds. No, it's a good thing that you guys are queuing up the mental processes that think about how the speeds would actually take place. But continue, brother.
All right, so here's another way of looking at the debunk.
Another way to debunk heliocentrism is that we can literally map which direction an eclipse has to happen and at what time. If the Earth is moving this way 67,000 miles per hour and the Moon is traveling this way 2,288 miles per hour, then to have an eclipse, be it total or annular or partial, the path of the eclipse must be from the south to the north during the March equinox.
You guys get that?
No, I have no
You
idea what
see
you're
how-
talking about.
Well, you saw the arrows, right?
Yeah.
67,000 miles an hour orbiting the sun. The moon, 2,288 miles per hour.
Yeah, I see the numbers. What's
around
the conclusion part?
Right. So you were talking about the two going two different directions and what that entails, right?
Yeah.
How it, right. So it is all mapped out here.
Wait,
And one of the things that you can see
we were
is
talking
that-
about the rotation speed of the Earth. The rotation speed of the Earth relative to the moon is slower. than the
1,000
speed
miles
of
an hour at the
moon.
equator. The Earth is traveling 60,000 miles around the galactic
We're
center.
talking
And
about
he's stating that the moon is
rotation
traveling
speed, not the movement
2,288.
speed. Rotation.
The moon doesn't
rotation
rotate.
speed.
We've only ever seen one face of it. It's very simple to pay attention. I think you guys are throwing off like, oh, we don't understand. This is retarded. Let's be adults here. At the beginning of this, we said we were going to look at stuff from an objective reality. We're just looking for truth. You're just constantly saying that everything we're showing is stupid because you don't understand it. How is this
No,
a
we
good
do
conversation?
understand it. We do
Well,
understand.
then
Look,
pay attention.
let him go, Ronnie. Let him go.
look at a clock. Look at the hour hand. The Earth is rotating at half that speed. May I share my screen for a minute? Just for a minute.
Now you're going into size relations and trying to
No.
mind control people out of reality. We're showing the
I'm
measurements of
going
the
to
speeds of the
demonstrate.
luminaries and your planet Earth and what would happen during an eclipse. It's simple.
Ronnie,
I want
just to clarify,
demonstrate how your diagram, your animation is wrong. I'll show you one image, and it will show how that diagram is wrong.
It's from the internet of the global heliocentric model. Jason
No,
didn't
this is
create it.
measured. This is,
no,
this
it
is
was
measured.
your number.
Jason didn't make that. Did you make that and create it all and put the no? You,
Ronnie, your
no, this is
numbers
a
were the
screen
wrong
cap.
part. Your numbers
It's
were
from
the wrong part.
timeanddate.com.
I mean, what are you guys saying? The heliocentric. You guys are debunking the heliocentric
No.
model live.
No.
Look at this. Now we have eclipses traveling north, south, east, and west, all
Ronnie,
in your
it's our
same
turn.
model.
Ronnie, it's our turn to talk.
Go
It's our
ahead.
turn to talk. So
Can you? I don't know. Can you see the diagram I'm sharing?
yes, you see the total
So-
solar
so-
eclipse path 2001 to 2025.
They're all curves. Your diagram shows with that red line, it shows the shadow in a straight line. Yes, the shadow travels in a straight line, but it appears on the Earth in a curve. Now, that's not just some meme. Those are actual measured things. If you're in those areas, you will see the eclipse. If you're out of those areas, you won't.
Mr.
Simple as that.
Sensible, that graphic, you're going to laugh. You are going to laugh because if all I had to do is hit play for like another second, right? We're just going to, oh, is it?
You got a screen share sound.
me?
It's hilarious. You guys are funny. It's fun. You know, I gotta let you guys talk more. I'll try to calm down.
No, that's fine. Interrupting is good. Dumpster fire gets more views, so totally fine.
Yeah.
All right, so now all I have to do is hit play on this video.
during the March equinox. The reciprocal is true during the September equinox. In this case, eclipses must happen from the north to the south. The path of totality promoted by heliocentrists shows that it
See, all you had
Okay.
to do is wait because
Well, obviously didn't know that was coming up. But then how can you explain those curved paths on a flat Earth?
Oh, it's real simple, but that has to do with sunrise, set, and elevation angles. When the moon's rise, set, and elevation angles are the same as the sun's at a new moon, that's when we have a solar eclipse. So you can path out the areas latitude and longitude wise that will have that type of an anomaly. And the neat thing about these eclipses is check out eclipse shadows, because what they do is they debunk atomism and materialism, because the shadows are actually now light instead of a shadow. So
And
eclipses are very special. Go ahead, brother.
And before we move on from this image, I know Mr. Sensible was bringing up the curved path, Mr. Sensible, what do you think would happen if I projected this image to your globe sphere? What do you think would happen to those curved lines?
Which is something I was going to say. Then it will appear as a straight line.
Oh,
Exactly.
okay, moving on.
Well,
Wait,
that's just
so
debunked you.
So I want to go back to your point there.
Our
Your
model
argument,
actually
your
explains
argument
it.
is that we would expect the eclipses to go in the opposite direction they actually do on the
Wait.
heliocentric model. That's your argument, right?
Let's go back to the actual argument. So
Yeah.
here you've got
There's
with
a big
the
orange
with the
line.
path
during
of
the March
the
equinox.
Right. So you're saying
The
the
reciprocal is
eclipse would go from the south to the north if
Due to
this
the
was
axis
accurate.
of the planes of the Earth and the Moon and the Sun and the galactic great axis. What do they call it? The great
If you look
attractor
at-
or something?
I just want to simplify this. Your argument is that if this was accurate, the eclipse would go from the south to the north.
at the March equinox.
Right. And you think that's the case because the moon is
Because we can
stationary in
because
that
we can
picture.
3D model it. Because we can 3D model it. So if you put the moon in rotation around Earth here, if you have everything dialed in, everything exact, you are going to see the shadow, obviously, because if the moon's path is inclined this direction, it's going to come from the south to the north. And then the reciprocal during the fall equinox, right? Because of the path of the moon now.
We go back to the other picture. We just stick with one picture at a time.
We got so many more though.
No,
We
it's
got
the
so many
same.
more.
This is
Right,
just a September
I
equinox.
want to explain using the other
Okay.
picture and going back to
All
the
right.
other picture. So you think that it's impossible on this situation for the eclipse to go from the west to the east. That's what you're saying.
We're not talking about west and east right now. We're talking about the fact that the totality path would actually have to come from the south to the north.
Right. So you're saying it's impossible for the totality path to go from the west to the east.
No, I'm talking about it going from the north to the south, not west and east. We already covered that one.
What? So, what you're saying literally makes no sense now. So what is your argument against the flat earth here?
We're not against the flat earth.
Or against the heliocentric model, my apologies. What is your argument against the heliocentric model in this picture?
The argument is that the eclipse would have to come from the south to the north during the March equinox, and it would
Right.
have
And
to
so
go
it's
from the
impossible
north
for
to
it to
the
go
south.
from west to east. That is, you're saying it is impossible
We're not
for
talking
the
about
eclipse
west
to
and
go
east
from
now. We're
west to
talking about
east
north and
in
south.
this picture. What?
We're talking about north and south, not west and east. We already covered that one.
Yeah, we're now onto the north-south path.
Yeah.
South-north.
All right. So you guys seem stumped. Let's go to the one
no,
about
not
time.
stumped. Not stumped. You talked
Okay.
about this. If this was all 3D modeled, you can download one of those sandbox, solar system or universe sandbox type things, and you can fast forward it. You can wind it back. You will see what we actually see, and it's
Stellarium,
not
too.
what you're showing.
This is heliocentrism's explanation for why we don't have a lunar or solar eclipse every month. That's what we're going through right now. This is the
No.
explanation. This is the lunar nodes.
No, we
This
can. We
is a
literally
map of
have
the
a
lunar
3D
nodes.
model of the heliocentric model that you can play. You can press the play button. You can watch exactly to scale what these planets do, and they map perfectly onto the data. I don't know what your argument here is. Like what you're saying that here is
You
a
can't
pretty
do it
picture
to
that you
scale.
don't like.
That right
that is
there
not
is an
to scale.
absurdity.
Yeah, how would you do it to
If
scale? You'd
anybody
have
Yeah, you can-
your modeling
one-
program would have to be like 400 miles long.
or
You
if-
guys
if-
have
if
no
Earth
idea
is
what you're
one
talking about
Do you
scale-
not know
scale.
how computer games work? Like, yes, we have a to
Computer
scale
games,
model of the solar system in a computer. Yeah.
It's crazy.
You cannot-
You'd have to put the sun in Austin. The moon would have to be in like Toronto, Ontario.
Do you not know how
in
computers
your
work?
computer model.
Do you not know how
But
computers work?
Yeah,
We
it's
do.
Let's move on.
So no, we have a computer model of the heliocentric thing where we have the sun to scale in a computer. It's digital. It's not physical. Digital to scale model of the sun, the moon, and the earth, and they rotate exactly like how we say they do in the heliocentric model. And if you press the play button on the video on the 3D model of what's going on, you can see the shadows and where they would go, and it predicts exactly map on to what we see in
And
reality.
so does our flat reality too with the Andrew Marsh website. We predict and map everything.
Independent of the flat reality, what your criticism is that if the heliocentric model is true, then we would expect to see the shadow going in the opposite direction that it does. That's false. If the heliocentric model is true, we would expect it to show up exactly in the way that it does show up. And so
No,
you're
we're showing you that it's
mischaracterizing
wrong.
the heliocentric model based off of this very simple diagram, which is not at
The
all
heliocentric
to scale.
model mischaracterizes itself when it claims that you can only have eclipses during the equinoxes when we clearly have it happening on the solstices.
no
The
one
next one
claims
was
that.
that
Literally no
the
one claims
traveling
that.
motions
No
of the
one
spin of
claims
the
that.
earth and the moon around the sun would indicate that the shadow would actually travel from the east to the west.
Right,
Right.
that's your
And
argument.
in
just explain
March,
why
in March,
wouldn't.
it would only travel the shadow from the south of the earth to the north. And Jason's put it here with your own model and showed you the fallacy
No.
and error in it. And all you guys can say is, well, look at this modeling program when we're showing you your own program right here. And
No,
the
you're
problems
using
that
you're
they-
using
isn't
a
our
not
I knew you'd
to
be
scale
denier,
model.
but we definitely have a lot more to show.
Let them
Bro,
talk,
you're using
'cause I
a
wanna
not
talk.
to scale model. So if I showed you a picture of the flat earth that I drew or that Nathan Oakley drew or something and said, ha, you see the whole flat earth model fails because of this one picture Nathan Oakley drew, you'd be like, well, that's weird. I'm not Nathan Oakley. I don't use that picture. That's a very not to scale model, right? You'd want an actually to scale model to represent your position. You wouldn't want it mischaracterized by a very simplistic model that is only there to express a single point, and then trying to use that model to explain everything about the universe doesn't really work very well, does it? Did you really think this argument through very well?
Do the two of you understand what it says here? Moon too high. Do you understand what that
Yes.
means? Okay.
Of course we do.
Do you see when they have it?
Yeah, but
At the solstices, right? Too high. 235,000 miles. You're talking about scale. Yes, the moon's going to be really too high, of course. It's only like 2,000 miles in diameter. So
This is not a picture
moon
of
too
every
high-
June. This is not a picture of every June throughout history.
Yes, it is.
No,
because
it's not. No,
It's the solstices
no.
and the equinoxes. They don't change. So solstices and
change.
equinoxes.
The
But
Earth's tilt and orbital
What
mechanics.
day
we
do you
don't
think
get a
the
new
solstice and
moon. We don't
equinox
get a
is,
new moon
TJump?
on the first of every month or whatever. It doesn't equate exactly with our calendar months or where we are around the sun.
How far
The
far
dates
of
of the new moon slowly go forward or backwards, whichever way it is.
how far of a deviation do you have from equinox and solstices
What do you
from year
mean?
to year? How much of a variation? June 21st or June 22nd, right?
No, I'm not talking about that. I'm talking about the actual
December 21st
phases
or
of the
December
moon.
22nd.
If you had a new moon on, pick a date, December the 22nd, then next year you will not have a new moon on December the 22nd or just at the tail end of it. The year after, it would be slightly different. It's a slowly changing cycle.
Yeah, it changes over 3 months in this
Therefore,
cycle.
your
So
diagram does
there-
not cover every
it's not my
every
diagram.
solstice.
This is heliocentric. This is
No, because
timeanddate.com.
if that's June with your diagram there, if that's June the 21st or whatever, then the next time the Earth has reached that point around its orbit, the moon will be in a different position. It won't be. You don't have a new moon on exactly the same day every year.
I understand. You have to have a new moon near it though. And so lunar node. Let me make this real simple for you guys. Lunar node. I took the picture right from, here it is.
There it is.
Right. What is a total lunar or eclipse? This is the graphic that I took and used. Right,
Find
so
other
it's
ones with dates on.
They
All
want
you
a
have to
different
do is
graphic.
all
We
you have
need
to
to
do is
move
look at
on.
the tilt of the Earth. Yeah. So
We need to move on. They're not understanding the argument. That's fine. That's fine.
So-
they can
so
say they
here's a
disagree, and that's
website.
it.
Wait, here's a website, the Sky Live, where it has all of the orbits to scale, where you can type in the date and you can show exactly what's going to happen on those dates.
And we
in
can
the
do that too on a
heliocentric
flat
model
plane.
and the shadows.
We can
in
do
this
that
one,
too.
you can just put in the date of wherever you want on June and see, oh, is there an eclipse there?
Put that in your
Yes,
chat. I'll save that website and see what anything else I can glean.
Cool,
But we've
yeah,
got
just
so many things to prove.
3D model to scale of solar system, and you zoom in, and then you press the play button, and you type in the date, and look, oh, look, there's an eclipse with the Earth and the Moon on June.
You know, they
No
were
one claims it's
predicting
impossible.
eclipses long before the heliocentric sphere Earth model even existed,
you
right?
claimed,
you think that an eclipse prediction proves your sphere, your laws?
Bro, your claim was that this would be impossible on the heliocentric model. Here is a literal model of heliocentrism where there's the sun in the middle, there's the Earth over here, and there's the moon here. And guess what? You can get eclipses in June in this model, which is heliocentric. Even if you don't believe this model is correct, this thing in a computer where the sun is in the center can get eclipses in June, which proves your model wrong. It proves that yes,
heliocentrism wrong, not our model wrong.
Heliocentrism states that you can't have those types of eclipses happening out of those nodes. You're not looking at your own graphic. I swear.
All right, we've got one more debunk,
does
and then
what
we
you're
can.
saying it can't do.
We got one more debunk in this video, and then we'll move on.
Now you will notice that the moon is defined as having an orbit that is tilted 5 degrees to the ecliptic plane. That 5-degree tilt is defined to the ecliptic plane, not Earth's 23.5-degree tilt in heliocentrism. As you can see in each of these diagrams, the tilt of the moon's orbit is contrary to the tilt of Earth in heliocentrism. So now that you have the lay of the land,
Let's jump ahead here a little.
Equinox and the September equinox being labeled as the nodes. Each of these nodes are the only time eclipses of the sun and moon could ever take place. Looking at the diagram, we can see that there are only 2 possible times this could happen, and that it is at the equinoxes which have been labeled nodes. Let's zoom in on the March node, as this will be the easiest to see. In heliocentrism, the moon must transit in front of the sun in order for a solar eclipse to take place. Now, as we know, in heliocentrism, the Earth is moving 67,000 miles per hour around the sun, and the moon is traveling 2,288 miles per hour around Earth. So we see here at the March equinox that Earth is moving 67,000 miles per hour this way, and that the moon is moving 2,288 miles per hour this way. With Earth having a diameter of less than 8,000 miles, the transit of the shadow would take roughly 6 minutes and 56 seconds at the combined speed of 69,288 miles.
All right. You guys want to test the math?
I'm not going to test the math, but what you're forgetting, your diagram is showing the orbital inclination of the moon at one angle's the wrong word, but for instance, can you just go back so you can see the diagram without that maths thing over the top?
Yeah.
So you've got I mean, sort of center top of the picture where you've got the 67,000 miles an hour. You're showing the orbital tilt of the moon at a certain angle as opposed to the plane of the ecliptic.
Yes.
That processes, it changes, it cycles over about 18 and a bit years. So what is true in that diagram today won't be true next year or the year after or the year after that.
And how far do you propose that you think it's going to drift, up or down?
No, it's processing.
Okay,
like
how far do you predict that it will process, north or south of that path on its ecliptic orbit?
No, the moon will remain at the same orbital inclination as opposed to the Earth's orbital plane, but the direction of if imagine it like a spinning top changes. It processes. Right now, you've got the inclination leaning that way, but in however many years, it's leaning that way.
Yeah,
so
I read
it
an article
changes
that said humans are causing the Earth to wobble more in climate change, right?
We actually understand that 19-year cycle with the moon, and what it's talking about is So like the farthest it travels north. With the sun, we talk about the tropics being the farthest that it travels north or south. With the moon, it has a wider path that it travels between, and it goes through a cycle where it has its most northern, farthest that it'll travel to the north, farthest travel to the south, and it is a 19-year cycle. We get and understand all that, but that's not explaining in a way the debunk of heliocentrism right here, because what we're talking about is combining the speeds because they're opposing each other, right? And then the mass, what it's going to tell us is that the length of time that it would take for the shadow to go across the face of Earth is 6.9 minutes, right? Because one's 8,000 miles in diameter and the other one's 2,000 miles in diameter. And then you combine those speeds. And so under 7 minutes is the length of transit of the shadow in heliocentrism.
Over a point. So if you're stood there watching an eclipse, then I can't remember the exact figure, but the maximum length of eclipse you could see is about 7 minutes, I think, something like that, 7.5 minutes.
I've got the information.
But the actual eclipse, from when it starts to when it ends, can be several hours.
That's exactly what the point I make. So right here, the record.
Oh, there we go. 7 minutes 32. Not bad, eh? From the top of my head.
No, good job. So we're talking about totality now, right? Mm-hmm. Totality.
Yep.
Not the duration of the eclipse.
That's right. Totality for
an observer.
Yes. So this graphic right here shows the duration of the eclipse, and this one shows the length of totality. All right, and you'll see that
across the face of Earth took over 5 hours. So the first debunk of heliocentrism here is that the length of solar eclipses that we record and witness are much too long for the heliocentric model.
But you just debunked yourself.
No,
go back halfway back. There, stop there. You can see that totality is that little black spot in the middle. That passes over an area that takes a maximum time of, as we saw, 7 minutes 32. The wider penumbra, where you see a partial eclipse, will last longer. But the actual eclipse as a whole, from start to finish, as it is traveled across the face of the Earth, could be several hours. That's not a problem.
No, it is, because all we have to do is go back to the graphic and
the math of your orbital mechanics on your spinning Earth and your spinning moon opposing each other.
The longest the shadow could be cast across Earth is under 7 minutes because of the speed of the moon and the speed of Earth. All right, that's the longest, under 7 minutes, because of the speed of these two things and the sizes. The mass are there. Nobody can deny this. All eclipses would have to be less than 7 minutes. Yet we have totality in the range of 7 minutes.
No, that's dumb.
Well, you guys have to take away all the movement and measurements and say that everything is relative to make it work.
No, like we can literally
the total totality to the duration totality.
Wait, this is very easy to prove wrong. Like you could make a computer model that has all the same numbers that we use, press the play button, and just count how long does it take. It's very, very easy. Like this has been done to death to prove you wrong a million times. Like literally, this is the easiest claim to prove wrong of probably all of yours, because all you have to do is make a computer model. You don't have to think it's real. Just say make a computer model that has all of the numbers that NASA uses, press the play button, use a stopwatch, problem solved. Like literally, this is very easy.
You do understand that these numbers are at a scale that there is no possible way to show any representation of it. If you made something the size of a pixel, you would need to have a TV screen the size of a football stadium in order to be able to.
That's not how computers work, Jason.
We're talking about
yes,
true
it
scale.
Is.
No, like you can
scale.
zoom in. You can zoom in to looking at the moon and the sun, or just
when we
shadow.
Zoom in, you tell us that it's not valid. Now you're telling us we need to zoom out. You're flip-flopping. We got to move on. You got so much more information. We can accept that you don't agree with our premise, and we can move on.
So you can make a model in a computer that obeys rules, and you press the play button, you watch it.
You can make a model do anything.
Like these
what are you talking about? We're showing you your model, and we're showing you how it's debunked. It's
not hard to understand.
You can't come back with, we can model it to make it work. I can make a Mobius infinite Earth and it'll work.
Wait, stop, Ronnie. So your argument is this is impossible on a heliocentric model, which means if in a computer I can make a heliocentric model where this happens, that proves you wrong.
All right, provide it to us. Provide
There's
it.
lots of
said
them. I
there-
already did. I
there's
did
no
earlier. I
software.
literally gave you
No.
an example of one earlier. There's lots of these. These exist. Like, just
We'll
go to a solar
further
system
check out your website
model
after.
Send us
generator.
send us
These
the
are
link.
common.
We'll check
These
it
are
out.
extremely common.
And if we're moving off
Go
from this,
to
what I
a
would like to
heliocentric
see
model
is
generator.
But then all we need to use is stellarium, and you guys are going to say debunked, right?
I don't know what that means.
Why
Let's-
even go
let's-
to?
yeah, stellarium. Use that.
All right,
But
yeah.
what I would say is, how the hell can you explain an eclipse over a flat Earth?
Yeah, I've got a video that does it.
I bet you have.
Yeah, keep moving on. Keep moving on. Let's keep going.
So-
This was just the intro.
Yeah, this
Oh
was
gosh.
yeah, this was when we debated Red's rhetoric
Space
and
engine.
Sean Hufford. They were absolutely unable to respond to any of these. Let's see if you guys can do any better. So this was one of the globe debunks that we used
Wait,
on.
just to clarify,
Yes. For
I was
Earth
just
to ro-
given a link in the chat. There's a one called Space Engine. It does all of this for you. You just download it. You press the play button. You can do all the calculations. You can zoom in, see exactly what it does. You can count it. Use a stopwatch, see exactly how long it takes for all of these things. And
We know how to test it.
even if you don't believe this is true, the fact that this model exists and shows that the exact time that it would take for the eclipse to happen and it doesn't correspond to your numbers proves you wrong that a heliocentric model can't account for this, because that literally is a heliocentric model in a computer program that does account for this.
We'll test it. So check this out.
Space
rotate with the motions
spaceengine.org.
defined by heliocentrism, we could feel acceleration and deceleration as demonstrated in this experiment. Not only do we not feel, nor can we measure any acceleration and deceleration, but Ares failed to detect any movement of Earth whatsoever. We demand the defendants provide measurable, repeatable evidence for the acceleration, deceleration, and movement of Earth. Without
You guys see what's going on here?
Well, we do feel that those what are the arms called? Foucault pendulums. They exist. There you go.
It's not a Foucault pendulum.
No, but what are you talking about? The fact that as we're supposedly turning around the Earth, sometimes we're going with the orbit of the Earth, sometimes against it, so our speed is
Nor-
changing. Is that what you're saying?
So what this is a demonstration of two motions of rotation.
Yeah.
Yeah. Okay.
Yeah, it's got a marker right here that it draws on a pane of glass as it's traveling by. So they've got the wheel rotating here and traveling in a linear path, which would be mimicking Earth's rotation, right?
Yep.
Okay.
All right. So this is you could put an accelerometer onto this tip of this marker right here, and it's going to measure what?
can we measure any acceleration and deceleration, but Ares
See, because it comes to a full stop and then turns back upon itself. So if you were to put a mark,
I know what you're saying. So if that wheel going along is the Earth, you are the marker pen. Then as you're orbiting the sun, you're going at one speed and you're slowing down to almost stop. And yeah, that's a straw man.
No, it's physical, repeatable, observable evidence. You can't throw a straw man without an actual backer to that. We're showing you what something does when it's spinning in two different directions.
Yeah, you're talking.
What? You can't
spinning.
straw man that. A straw man would be us trying to.
You're going to let me explain.
Go ahead. Sorry.
Yeah, that's all right. Like we said before, I know we'll talk over each other from time to time. That's fine. I know there's no nastiness or anything. You are sat on the Earth. You are held there with gravitational attraction. You are. I mean, we've got those arcs there, that the humps, as that demonstration was traveling along. It takes us 24 hours to make a full rotation.
and what is the speed?
Sorry.
What is the speed of a person? Let's say this is a
I can tell you the
representation
speed.
Equator.
One revolution per day.
But how
It's
fast is it moving at the
I forget,
equator?
In miles per hour.
0.094 RPM.
How fast is it moving at the
It
equator?
doesn't matter. You're confusing
matters.
angular.
Per day.
Wait. You're confusing angular
1,000 miles
momentum
per hour
One
at
sec.
the
You're-
equator.
Wait, stop. So you're confusing the angular momentum and angular change versus straight directional momentum. Those are
confusion.
different things.
Angular
So like
velocity.
that's
So
the line thing is us.
if you
right?
have-
the line
me
is supposed
talk.
to be, the marker is supposed to be us, and the rotating thing is supposed to be Earth. And relative to the sun, we hit a point that's closest to the sun, and then the Earth keeps going.
We're not
and then
talking
we-
about the sun. This is about the Earth's motion. Nothing to
But
do with the
that's what,
sun.
that's
Around
what
the
this
sun.
demonstration is showing.
Yeah,
You're
so
showing
if
it
you have a
around the
record,
sun, right?
one of those 33 records, a nice big record, right? It's rotating at 33 revolutions per minute, correct? So if you measure close to the center stem, right, it's going to be rotating very slow, but on the outside edge, it's going to be rotating very fast. So
No,
angular
it's rotating
velocity,
exactly the same speed, 33 revolutions per minute.
So why do
No,
people want
we're
the
talking-
inside of a racetrack? Why do they
We
not
wanna-
take the outside?
we want to talk about the miles per hour around the outside.
I know you
not-
do, but it's meaningless.
What?
No,
this.
your 1 revolution per day is meaningless.
Yes,
No,
that's
'cause
nonsensical
Nelson-
thought experiments like Isaac Newton thought he could shoot a cannonball up into the air and it would just circle the earth forever. That's meaningless. What we're
Yeah,
showing you is
well,
the actual measurable, repeatable evidence of what would take place if the earth were spinning and moving forward in direction. You can't nullify
Okay.
it with saying straw man or any other fallacy. You have to accept this as actual proof of evidence of what takes place when you have two different motions. You have a rotation plus a forward motion. We're showing
Yeah,
you
but
that there would be an
pick-
acceleration and deceleration. There's no way around it.
In relation to your path around the sun.
Not
is
into
what you're
any
talking-
relation about the sun. This is talking about an object
No, but
spinning and
we
moving
just said
forward.
this
Take
t-
the sun out of this, I said. This
Oh my God,
isn't-
Ronnie,
do
Ronnie, we're
you
just-
see
we're
a sun
using-
on the screen. I do not see a sun in this picture.
Ronnie,
This is
Ronnie.
the
Yeah, right. I
Ronnie,
understand.
let him
Ronnie,
talk.
Ronnie, you're just saying like if you were traveling through space on a spinning Earth, like so the sun, we happen to be traveling on the sun. It's irrelevant to our argument. So yes, so if the Earth was rotating, just spinning through space, not around anything, that's the argument. Okay, fine. Yes. And what is the angular rate of change in that speed?
what
Yeah.
you would notice is as you went and you would slow down to a complete stop and then you would be accelerated forward again through the arc. It's showing you literally on the screen. And this is
Not
like 60
feel,
years
nor-
old.
But you just
Just
said
look.
you would slow down in
Yes.
relation to
Look
what?
at the
You-
drawing.
listen,
Look
hold,
at the
hold on,
drawing.
Ronnie. You're sat in your chair for 24 hours, okay? So what you're saying is you'll have sped up at one point, slowed down at another point. In relation to what? Your chair hasn't moved. It's still sat in the middle of your living room. In relation to, that's what I said, the sun. You could be traveling in a path that orbit with a radius of 93 million miles, takes us a year to go round. If you actually had a traced line where it is and looked along it, it would look dead straight. It's big. So
again, you're taking things to size comparisons like Neil deGrasse
It
Tyson.
matters.
Of course you wouldn't see how big you're a tiny grain of sand on a beach ball. No, this is all nonsense. What we're showing you is the two motions of movement for a rotating forward directing object has acceleration and deceleration. And none of these things have ever been measured. Just like my chair isn't going to move if I don't move it because Earth is motionless and we can test it and repeat it and we can go out and show it. That's what we said we were going to do.
So with an accelerometer on the tip of this thing right here, it would be showing coming to a full stop and then going forward again.
no,
Coming to a
because
full
with
stop. and
your
then going forward again.
accelerometer is on the surface of the Earth. If you placed it on the table, sat it on, or Ronnie's holding it, sat in his chair, as I was saying, then his movement is constant at 1 revolution per 23 hours 56 minutes or whatever it
Well,
is.
We're showing people that have the ability to just look at this video that what you're saying
Yes.
isn't true. It comes to
Okay.
a complete stop.
Now listen, relative is critical. Just wind that video just about halfway so that wheels.
What do you mean
about
by
halfway-
relative? What do you
I'll
mean?
explain.
Clarify.
I'll explain. Right. So now what we've got is we are sat still. That wheel is traveling past us, relative to us. If we were on a camera that was on an arm looking straight at that wheel, all we would see is that. And
All that
everything
would
else
change is
going
our
on.
perspective and parallax to the spinning moving wheel. The spinning moving wheel is
No,
showing
not
us
parallax.
exactly
No,
what
not
it
talking
is
about parallax.
and what it's doing. You can't say that if we were moving now. Everything that you're
What you're looking
interjecting
at,
here
that-
is just
that-
taking away from the simple, obvious logic understanding of what Jason's showing. If you guys could just say that you understand what we're showing, we could just move on. We got
So
much
I
more.
understand. So if we put, let's
That
say that we
traced out the-
spin the camera.
the
Let's say that we're
line
spinning the
really-
camera and we put an accelerometer just on the table. Would the
The,
accelerometer?
Why do you want to
measure
spin the camera? I don't understand.
Suppose I'm holding a camera and spinning it in my hand,
rotating
spinning
around
it to make it
center
look
of
like
that wheel.
that pattern.
Then let's put the accelerometer on the camera and we'll measure
So
measure
say-
the motion of the
my
camera.
analogy, stick with my analogy, Jason. So my analogy is I'm spinning the camera and the accelerometer is on the table. Will the accelerometer measure anything?
If the accelerators, if it's on the table, it will not measure anything because Earth is not moving.
It's fixed. And that's
No,
how
no,
all the
no,
devices
no.
that we
Relative to the
measure
camera.
things off of actually
Relative to the
work.
camera. So the camera's spinning to make it look like that image.
Then
the
you
accelerometer
put
on the
the
table will measure
then
it.
you put the accelerometer on the
So
camera
how-
to see what motion
Here.
you're applying to that. Right?
TJump, how many miles an hour is your car going when it's in park?
A lot.
is going 1,000 miles an hour at the equator, huh? But
Yeah.
even though your measuring device, logical in reality, says it's moving 0 miles an hour, right?
It is
So
moving
let's move
0
on.
in relation to the surface of the Earth.
All that is nonsensical thought experiment. We are going to show you verifiable, researchable, testable, repeatable evidences that we can go out and actually visual. We've got clouds behind the sun to get to. Now we're going to go into curvature.
Okay, let's go to curvature.
So what you're seeing here is one of my first videos that I ever did. This is from like early 2016. So it was my first flat earth proof video. And so it just so happened that I lived on a river here in Austin that we had a big flood. And so I paid really close attention to what sea level was and how many feet above sea level we were, because we were on the river where it flooded. So this right here is a study of my situation. Now, the first thing we got to do is we got to agree on the curvature formula real quick, guys.
Go on and tell us what it is.
Do you understand that 8 inches per mile squared does not give you enough curvature?
It doesn't give you a curve at all. It gives you a parabola.
Well, it gives you a slope. It's right here.
No, that's a straight line.
It's a slope.
It gives you
So
a parabola.
The squared, the 8 inches per mile squared means it goes up exponentially. It would be a parabola. It wouldn't be a line.
But I'll grant you that at relatively short distances, it can give you a rough guide.
Right? It's
Should,
not too
it
bad,
should.
but it doesn't give you enough curvature for it to work for heliocentrism. Right? It comes way short. We got that?
Well, to be honest, most flat earthers say the other thing, and they'll go on about however far out you go, and then it's an infinite or virtually an infinite drop because it's a parabola.
Yeah, it comes up way short if you actually test it.
Well, it's a meaningless thing, but I know that a lot of flat earthers use 8 inches per mile squared.
But we're gonna use it for rough means. You agreed that it sort of works in a rough way
For a
So
short distance. Yeah.
Here's the premise. My place on the river was 140 miles from the coast here in Texas, and so what I did is I modeled this up, and what we got here,
Black Swan.
what we got here is at 143 miles, the total curvature would be 13,632 feet. All right. But I was 400 feet above sea level. Right. So I subtracted that out. So we've got 13,232 feet of drop that we should have from the mouth of the river to my house. Right. So all you have to do is have the observer positioned right here where the river flows into the larger body of water. And from this observer's vantage, if they look back towards my house, right, my house would have to be 1,200 feet below. Yes, because everybody places themselves at the top of the globe.
Oh my goodness!
Always.
You're not going to what's his name? 10th Man's Alice and Bob proof, are you?
We don't know who that is.
No, never heard of him.
Oh right. So you got that lady there. She's looking to the left and can see that the horizon has dropped. You put Bob at that end. He looks to the right, but she's dropped. So why isn't it curving like this? Is that where you're going?
No. The fact is, for the person.
So if you're just talking about the fact that what are you saying? Your elevation at your house was about 400 feet. Was that what you're saying?
400 feet above sea level.
Okay,
yes.
400 feet above sea level. I don't know how far from the sea it is.
143 miles. It's all in the graph here.
Right. So all that means is from that start point of your house to the mouth of the river, there is a drop of 400 feet. That's all the drop is. Do you not get that? The surface is curved. Your house is 400 foot roughly further from the center of the earth than the mouth of the river is.
Yeah, so this is
rivers don't flow because of the curve of the earth. They flow purely due to elevation.
Yeah, well, rivers wouldn't work on a globe. And this right here is the demonstration of that.
Yeah, so what's the problem with the image? I don't see the problem.
You don't see the problem. So the observer right here that's at the mouth, that like Mr. Sensible is saying, we know that there has to be 400 feet of elevation drop for the water to move from the back of my house into this body of water up here, right? There has to be that elevation drop. But yet You don't believe that there has to be elevation drop?
Wait,
for-
so
No,
your
there
argument
has
is
to be
that-
elevation drop. That's not curvature. If
Wait,
you
so
took
you're
an
saying that water
absolutely-
can't go from your house to the river or something? Is that your argument on a curve?
I think where he's coming from, Tom, is if you had a perfectly smooth ball, Jason, the elevation is like you stuck something on the outside of that ball. So it's flowing from the highest point, the furthest point from the center of the ball, back to the surface of the ball, mean sea level. That's all it is. It's got nothing to do with
Sea
the
level. I
curve.
like that. Can I show a meme? Can I interject?
Yeah.
Memes are
Let me
good.
stop screen sharing. I'll screen share real quick. Let's see if this works. Trying to do this so that everybody can see. So you guys should be able to see here. We're starting off with the Nile. Right?
Oh
Is
my
it clear?
God.
Can
It
everybody
That's the
rhymes
see?
same
with
thing
denial.
he's talking about.
So a river that flows north over 4,000 miles against the supposed curve of the globe sphere Earth. The impossibility of this further proves Earth is actually flat, and water always flows downhill to what? Find its sea level. You can be in denial when you can't accept this fact and choose to believe that you live on a giant spinning sphere. Did you guys want to comment before I move on to the next river proof?
Yes, Ronnie.
Go ahead, please.
I really don't wish to be rude, but that meme is dumb. I mean, the difference between the mouth of the Nile from the source of the Nile could just be a couple of feet. It doesn't matter the length of it. The water is going to flow from the higher point to the lower point around a curve, because it's not going over a hump or anything. It's not running down the curve or trying to run up a curve. It's going around a curve.
Around a curve. That's what you say. Well, let's go on to a little bit more evidence to help you understand what I'm trying to say. How about the Suez Canal? Earth is definitely flat. It's a 120-mile long canal, right?
Yep.
Sea level waterway located in Egypt and connects the Mediterranean Sea with the Gulf of Suez with actual zero curvature allowance in its construction. And the next meme I have right here is an actual diagram of the elevation map showing that it's perfectly level for over 100 miles. And guess what? The kicker of this is, wait 1 second, Mr. Sensible.
Yep.
There are no lift locks in this dealing with the supposed. Do you understand that that's 9,604 feet of curvature missing?
That's not curvature. It's the same level from one end to
Can't
the other.
tell me
As
that
it's-
Earth is
No,
flat,
hold
but
on,
it has
hold
a
on.
curve.
I waited for you, Ronnie. I wait for you. Sorry, I've forgotten what I was saying. It's level from one end to the other. Therefore, it doesn't need locks to lift or lower boats.
You're
It's
saying
the same
curvel.
level.
You're using the word curvel, like curves are somehow level. No, it's absolutely flat. And you can see right here on the diagram of the elevation map that I have right here, there is no locks. And look, it even is scalable. This is actually an elevation map that you can measure. It goes from this section all the way to this section flat.
And what's the elevation at one end, Ronnie?
Sea level.
What's the
Sea
elevation?
level.
What's the
Sea
elevation
level.
at the other end, Ronnie?
Sea level. If there wasn't a
Yes.
sea level elevation,
Yes,
they
it's
would have
not
to
going
have
up.
lift
It's not
locks.
going down. It's maintaining the same
Right.
level.
And there's not a water hump.
And there's no humps.
No. What do you mean? It's not? There is no.
There's no way you guys can deny or take this away. Let me do a couple more, and then I'm going to send it back to Jason. We got a bunch more here. Let's look at this.
Wait.
Let's look at
No.
another
Let's
real-
go back. So when it says level, as in like sea level,
Sea level.
if we're on a curve, the sea level is going to be curved, right? It's
You're
gonna be
calling it
curved.
curvel, not
Right.
not level. You're calling it curvel. Let's get this right,
Curve.
so everybody in the audience can understand your
Curve.
crazy
I get what you're saying. It's
non-reality
curved-
mind
it's
control
curved
tricks
level.
that you're trying to
Yes.
pull. Curvel, level
Sure,
on a
sure,
flat plane
sure,
in a
sure.
simulation reality like we teach, or curvel like it would be on a sphere.
that
We wouldn't say
picture-
things were sea level. We would say it was sea curvel. Just
Right.
get the
So
terminology
if
right.
we're on a curval, say if we're on a curve
Okay.
L or whatever you want to call it,
Mhm.
I wouldn't need any sea gates to go up and down like 1,000 miles.
Yes, you
right?
would. How do you know how the
Right.
properties of water work? They find their level, which is sea level. They don't flow up hills or down hills.
Ronnie,
If you can
what-
show
what
a
is-
diagram of a spinning sphere with water clung to it, or any
Oh my
experiment at all where you can show me water flowing upwards in elevation, show me. Show
It's
me.
not flowing up.
Evaporation. Are we going to talk about being a gas? Let's
Do
stick
you
to
know
the
what
actual
elevation
picture
is,
on the
Ronnie?
screen right here. This is 100 miles with zero curvature, zero locks, and there's missing 9,604
Now,
feet
hold
of
on.
curvature.
It's showing zero changes in elevation.
Yes,
That's
that means
not-
that it's flat. Do you see
No,
a
it
curve in this
doesn't.
map? Do you see a curve?
Well,
So
no,
you're
'cause
telling me
that's-
that when they designed this and built this, they measured to the center of the earth and then they ran a string
No,
and they did
no,
a
you
pair-
don't need to.
What you know,
don't
which
need
you're
to.
suggesting is absolutely crazy because they actually use the water to level it because water
Yes.
always finds its level. Let's look at
Yes.
this picture. So if you're claiming that we live in a curvelle, let's look at a real life experiment here. Someone's taken a mirror and they've shined a light on it and they've put a curve onto it because you say we live on a curvelle. This is what it would look like. Look at this surface, which is flat, and which does the real life picture match for you guys? Does it look like we live on a curvelle? Do you see a spotlight out here on the water, or do you see the light fully extending all the way to the observer?
I have no idea what I'm looking at right now.
Okay, I'll explain it again. At the top of the screen, we have a curved surface with a flashlight being shown onto it, shined. In this one, we have a flat surface with that same flashlight being shined onto it. And below, we actually have an observation of the sun pointing at an observer. What do you think this observation matches? Your curvelle theory over here on the left?
Scale will make a difference. But Ronnie, I cannot.
No, you
believe
cannot
don't-
talk about scale. We're showing you an actual observation of a picture taken of Earth. I'm not telling you
Ronnie,
to imagine how
Yes,
far.
but you're comparing it to two bits of glass, wet glass or whatever. But Ronnie, the big thing is what you're not grasping, right?
Mhm.
Is there is a difference between elevation.
No, what you're
Yes,
not
yes,
grasping is it doesn't
because-
matter how big this curve is. If you shine a light on a curved surface, you get a spotlight
No,
effect.
no,
you
you
can
don't,
model
Ronnie.
this in any
Ronnie.
3D modeling program. When you shine it on a flat surface, you have this. And you know what? Here, this is what you guys want to do. All the globe earther, Kabbalistic heliocentrics do is take you to thought experiments. All your proof is going to be in these squiggly lines, when what we're continuing to do and will continue to do forever is show you observable, repeatable, measurable evidences.
By
Jason, I'm gonna
ignoring
give you
the
the screen
actual
share back there.
evidence.
They're
By
just
not understanding.
not responding correctly.
I mean, I can show you a picture of a curved, of a tank of water that has a curved surface. Have you ever heard of tow tanks?
We can go into all the stuff. We can put salt in the water and sugar
No,
and
no,
make
no,
the
no,
lights
no, no.
bounce,
I'm
and we can
talking
do
about
all
the
this. I want to
surface.
look at actual physical reality, observations
yes.
that we can all go
From a
out and do. That's what
university.
we said from the beginning, and we're going to be sticking to that forever.
Can I share photo?
What do you need to share? Because I'm ready to
Yeah.
keep moving.
You're on
Yeah,
to
I know, but
perspective
you
now.
like to-
we
you guys
we
like
haven't
to
gotten a
move
chance
past
to
the respect-
respond to what Ronnie had said yet. So we
Yeah.
still need a chance
Okay,
to
go
respond
ahead.
to what Ronnie said.
And make
Thank
sure you
you.
guys are super chatting over on TJump's channel. We want
Yes.
the good super chat questions. I'm really looking. We still have what? Jason, you still got. We want to talk about what else do you want to talk about? Then we'll get to your responses. Jason, like, give us a blow through. You wanted to go into perspective. You've got what else do you have? How
Wait,
far
no,
can
we
see?
still need a chance to respond to the gibberish you just said about.
I was giving you a little bit of time to come up with your response. I was talking to give you that time. But if you're ready, go ahead. I'll mute.
Yeah. Can you see that image?
Yes.
Can you see that image?
Well, so I just want to say that if I take a flashlight, put it on top of a basketball, it'll create a long line. It won't just create a little dot.
Well, yeah, you're taking it to a crazy, nonsensical straw man, non-reality. I showed you a
said
picture
any
of a
ball. You
surface
said any
reflecting
ball. If I
light.
shine a light on any ball, will it create a line?
You can't
Yes.
zoom into a. You guys just taking it to nonsense realities. I showed you the evidence.
Well, you said that, Ronnie. You can see that picture of that tank of water, yeah?
I can see that. Yes.
Yeah, that's a tow tank. The construction that's across it is the gantry, which runs on those rails. The tank is used to model ships, how they handle waves and so on. When that tank was built, it's at Southampton University. It's the Boulderwood tow tank. It's 138 meters long. Those rails have to be perfectly even height above the surface of the water. I know it's showing waves in it right now, but they let the water settle. Those rails are set so that they're the same height above the water, so it doesn't affect the gantry and affect all the readings. From one end to the other, there is a curve, a hump in the middle of 0.6 millimeters over a length of 138 meters. All those red mountings had to be adjusted using a microscope and a pin touching the surface of the water. And as I said, it's a curve. That was measured against the water. That's the amount of curvature you get in a 138 meters long tank at the latitude of Southampton University. That's measured. There is curve, but the surface of the water is always level. The gantry,
Where did you measure the curve? Where? What was the curve measured on again? Sorry?
The water?
They adjust the rails, so the top of the rail is the exact same distance above the water. Yeah, do you understand?
So we're making waves and we're measuring the distance.
It's flat.
Forget the
Ronnie.
waves.
Flat.
Oh, it's flat.
Here you
No.
go. Have a look at this. Forget the waves. There's the tank, and it's still. and there's a gantry running across. That gantry must not move up or down. Those rails must be the same distance above the surface. You see, they do have a wave machine for testing the models of the ships. That rail, or the rails on each side, have a curve of 0.6 millimeters over the length, because that's all the curvature is over 138 meters.
So you're taking it to a scale, but wait a second. Why is it then in your heliocentric model that the wave or hump of the Earth spinning would actually be larger than Mount Everest? How come nobody's ever filmed or viewed or observed this giant hump of curvature that would be demanded with the spinning sphere? Let's spin your pool here 1,000 miles an hour at the equator and watch what happens to it. It's just nonsensical what you just tried to do there. You in no way showed me evidence that I lived on a sphere. Now, if you could show me evidence, if you could, we're going to get back to Jason's point, but if you could, like, maybe we'll do another podcast. You could come forth with evidence to prove the sphere Earth with curvature, with measurements of Earth's rotation and everything else. I would be really interested to hear your side of it, but today we're hearing Jason's side.
What's this giant hump thing?
I have just shown a tank which is measurably having to conform, or the rails measurably have to conform to the curve of the water, which is conforming. But
no other bridge, railroad, or anything ever built in construction has ever had to take this into account. Drilling holes into the Earth, all these tunnels, none of them take this your demanded tank curvature into account.
Actually, they do. They just recently built new underground lines under the streets of London, and they had to be very careful to make sure they measured up, and they had to take the curve of the Earth into account. But what you're not understanding,
did they use water to measure the curve of the Earth, though? Right? They're going to use a water level.
Ronnie, can we all talk too?
What you're not understanding about water level, Ronnie, is water sits at a level where it maintains the same gravitational equipotential.
So are we going to go to Cavendish's lead balls hanging in his shed for you to explain to me the weight and how gravity works? Or are you just going to make me want to believe that somehow water is being stuck? Do you know how heavy water is? I'm going to throw it back to you, Jay.
All right. So we're moving on to perspective now. I've got this video called
what's this bulge thing? You mentioned a bulge around the Earth. What was the bulge thing? What bulge?
Talking about the water should bulge outward due to the rotation of the Earth, as does the Earth. And it does, Ronnie. But that bulge isn't suddenly just at the equator. It starts at the north and south pole.
If the Earth was spinning in the equator as its middle axis, yes, the mountain Everest of water would be at
Ronnie, let him finish. Ronnie, let him finish.
Yeah. If you had a model of the Earth as a beach ball about 1 meter across and squished it for to allow for the bulge, that's I forget, something 0.3 millimeter bulge. That bulge doesn't suddenly occur at the equator. It's a bulge starting from the pole, coming out to the equator and back again. It's 26 miles over the entire diameter of the Earth. It's minuscule.
All right. So moving on to perspective. This is one of the things that heliocentrists like to give flat earthers a hard time about. They ask about the ships going out and how that's not proof of curvature. Well, what we did is we set out to prove that happens on a flat plane. So in this video, I actually paid a model to walk down a hallway in a mall where it was air-conditioned space on carpeting, and so all the environmental factors. There wasn't humidity. There wasn't any of these other types of defects. It's in a 2-story mall here in Austin that the mall is built flat. The mall is actually not curved. And we're builders. We understand how things are built flat. So here you were talking about elevation, Mr. Sensible. And here I am filming with the camera at the floor. And I also film with the camera up at eye height. And lo and behold, when
is this like a video or is it just like a picture?
No, it's a video, and it was live streamed.
All right, and so what are we looking at?
You were looking at a model at the other end of the mall.
The white dress lady?
Mm-hmm. Yeah, it's gonna...
And what's the problem?
Yeah, what's the problem?
She's disappearing. And
you can see
she's disappearing kind of the guy at the orange pants, but I don't see what else.
This way,
you're not screen sharing that specific link. You're actually screen sharing the OBS scene. It's fine. People can see.
Yeah, we got what it was.
We're not trying to hide anything. We're all about coming out into the light. We don't try to hide.
You could see a reflection of that woman. But you could see a reflection.
Yeah, a little bit of interesting stuff starts to take place. Let's all tune in and pay really close attention to this.
Okay.
Right.
I see legs. Let's see, orange.
So we don't need
pants.
the music, do we?
Nah.
Yeah,
I didn't see anything. I saw a guy
Just
walk in
wait.
front of
Just wait. I just showed
we
you
just
the.
started it.
I just showed you the camera on the ground.
Well, show us the money shot.
Yeah, camera on the ground, pants.
She asked what I was doing.
And look,
And,
you've got all sorts of
Mute the sound.
reflection.
Mute the sound. Mute the sound.
No, we don't need
Mute the sound. Yeah, what you're noticing is that you can't see her feet. Can
No,
we
but
all
you can
agree on
see
that? Can we all agree?
reflections due to
Hang
density
on.
changes.
Do you, Mr. Sensible, agree that
Yes,
you cannot see
the
her
bottom
feet?
of her shoes. I agree.
Okay, thank you.
And the problem with that is what?
Perspective in your
She's
vanishing
beyond the
point.
vanishing point.
No,
From
she's
that-
not beyond
from
the
that
vanishing
Perspective
point.
isn't a
From that
criticism.
elevation.
The
What's
camera
problem?
has its own vanishing point, and she's about to cross back into it.
Yes,
She's. Mhm.
and
Yeah, but you can see reflections. That's due to.
We're not talking about the waves of
Yes,
reflections
but
that
it's
you're seeing. We're talking
distortion.
about
Can you not see
her.
it's distortion?
Mhm. Just wait.
And what
The
do you
camera
see when
doesn't-
you see ships and things on the horizon? You see this exact same distortion as well
You
as
can see
obscuring.
distortion, but you can see some.
It
perfectly
matches
clear
reality
shots.
perfectly. You can go out and retest this. All you have to do is find a long enough hallway in a mall. And if you want, take a laser level there and make sure you verify that all these different spots are perfectly level. And what you'll see is once she crosses the camera's vanishing point, you do not see the feet and she begins to be truncated from the bottom up until if this was a large enough mall, you would cease to see her again, roughly around 3 miles out.
and this proves that what?
Ships over the
Things-
horizon
things
and everything.
disappear. Things disappear from the bottom up on a plane due to perspective.
No, that's due to distortion. You could see the reflections. Well, that's what it is. I mean,
The
it's
camera,
it's mirage.
the camera is
isn't that?
sitting on the floor.
I mean, that's a
level.
clear shot there, but you can see the wheels of that buggy that are further away. It's not a
Yeah.
limit of the camera.
No, it's the limit of the camera's circle of sight because it causes what we have in reality is a vanishing point, right? In all realities, in all video games, you'll have a vanishing point. Once something reaches that, you will not see it anymore as it continues away from you.
Yeah. You can
Yeah, but
actually see at the middle of the mall when she starts walking out of the haze and
Haze, exactly.
yeah.
May
Yeah,
I
look
share an image?
Look at the baseboard and
Yeah.
this is a black rubber baseboard that's typical in commercial buildings.
And all distorted.
Yeah. Absolutely.
There are temperature variations. I know you said it's air-conned and that. It may be little, but at that distance and at that angle, the instant path of the rays of light is enough. to
You do
distort it.
understand that other people that don't believe in the same thing as you see this as actual physical evidence of how things are disappearing at the vanishing point. In reality, you guys can state whatever that you believe due to your pre-programmed indoctrination bias, but people that are watching this, Mr. Sensible, are starting to understand that as a person or a car or a vehicle or anything else moves away from you, it crosses what is called the vanishing point. And this is
Okay,
the reason
can I
why
show-
we
Sorry,
see
go on.
ships and other things disappear from the bottom up. As we drive towards something like the CN Tower, you will begin to see the top of the tower first. And as you move closer, you will see further and further and further until you're within the complete circle of sight of the CN Tower. You will see the whole thing base to the top. And this is all repeatable, measurable, and observable on a flat plane. And, we're just talking about the floor of this reality.
Can we
We
turn
actually
real
want to take
quick?
this into the luminaries and the heavenly understandings of things that we see in the sky, because most flat earthers, they just talk nonsense. They deny the observations. We also want to take it up a notch. This is just, we're completely explaining what Jason's is showing, the vanishing point and the, go ahead.
I was going to say, if you want to take it up a notch, I have an image I'd like you to explain.
Oh, and also just a quick question. Brenda asked, what is the circle of sight?
The distance that you can see into your vanishing point is your
Okay.
circle of sight. It
That's
travels
cool.
around you in a 360-degree perspective.
Well, may I show this image and then you can explain it?
Sure.
Okay.
Is it going to be, what is the perspective that Sly Sparkane and all them like to use, Jason, that you always laugh at, the non-reality perspective image, right?
Well, there you go. There's an image.
Yes, this is a great example.
Yes, well, will you let me explain something? If that's
Sure.
due to your circle of sight
Yes.
hiding the hull, how come you can still see the rigging?
So the
Which
top
is
of the
same
map, hang
distance
on,
a-
let me,
hold on. Which is the same distance away, but it's really, really narrow.
Let-
Yet you can
can I
still see
explain?
it.
So-
And no matter how much you zoom, you will not
yeah,
see that
you'll
hull.
never, okay, the zooming in thing I'll touch on really quick before I answer you. heliocentric model, and people that believe in NASA believe that you guys can zoom into the outer reaches of the universe. It's absolutely dog-do nonsense. We can only see what's in our 3 to 4 to 6 to 10 mile circle of sight. Jason's going to bring up the furthest sighted thing that we can see is 80 miles. The reason that you can see the mast top is because due to your elevation inside this three-dimensional virtual reality, that the floor of it actually is flat, the sea level is level. The mast, the higher in elevation you are, the larger of circle of sight you have, as well as you can be seen from. So the reason why you see the mast last is because as that ship continues to sail away from you, the vanishing point will continue to move up as the ship moves away. Nothing is moving up. The ship is moving beyond your vanishing point, and the top of the mast actually has the largest circle of sight. Therefore, it is seen for the largest amount of viewable time.
So what's actually
and all you would have to do, one more point, all you would have to do is rise in elevation, and what you would see is completely flatness from our perspective to the boat and further beyond. You can never zoom anything beyond your vanishing point ever. You guys can write this down, jot this into your mind. You cannot zoom something in once it's gone beyond your vanishing point. And I hope everybody understands.
Brenda asked a follow-up question. She said, why can we see the wall that's behind the model? Because the wall is beyond the vanishing point. We can see like the rubber stuff that you're talking about, the rubber part of the bottom.
Rubber.
It's just all nonsense. The mast is the highest part. You see the mast last. It has the largest circle of sight. Here's the diagram that Jason has on. It's explaining it.
Yeah, but you're skipping past, not letting us respond, Ronnie.
Go ahead. Question about the mall. The mall, we could see the wall and the rubber goo on the bottom of the wall behind the model, right? But that's behind the vanishing point, right?
Are you trying to state that you think that the mall is being curved up like a Lord Stephen Christ concave mall?
Well, you said we can't see her feet because
there is some distortion that happens at the horizon. Have you ever watched a car drive away into a sunset? You can see distortion everywhere.
Yeah,
what
I just showed you
her feet were truncated upwards due to the vanishing point.
You said we could not see things past the vanishing point, but the wall is behind the model.
Look, Jason raised his camera in elevation, and now on the left side, what you can see is her feet in full view and the floor being completely flat, not concaved up like your nonsense you just tried to spin it, and not curving down.
Ronnie,
because of the vanishing point of the camera.
No, because the camera is the same camera. She stood, I presume, the same
when he
distance.
Raised the camera in elevation, you have a
Ronnie,
larger circle of sight. You're not understanding what I'm saying.
Angle so that the light is
no, it's not a different angle. He raised an elevation. He live streamed.
Am I wasting my time here? I mean, I do want to talk to you guys, but you have to let us respond as well. I mean, those two images, I presume she stood the same distance away. The only thing you've changed, and assume you haven't moved the camera nearer, is you've changed the angle. Therefore, the rays of light from her shoes traveling towards you are following a different path. They're not being bounced and reflected around. And with my image, which I showed you, the ship, that was crystal clear. Two things. One, a flat Earth won't have a crystal clear horizon edge. And secondly, that's what is stopping you physically seeing the hull of that boat. If I lifted myself up,
I just explained
if I lifted myself up 50 feet, I'm still looking the same distance virtually.
No, your distance to your vanishing point gets much larger, and there is a slight drop in the angle to the relative vanishing point that becomes, I explained, the higher in elevation you rise, the larger your circle of sight.
It's all in this video if you want to see it.
One question real quick. Why is she so much bigger in the right one than the left one?
Due to the angle of perspective, but we're explaining to you.
Do
you think that somehow debunks that her feet are gone, and when he raises an elevation, you can see her feet because you've enlarged your circle of sight?
It could just be the cameras.
You think that the waves? Okay, if you guys want to sit on that as your debunk, because it's wavy, you're totally missing the actual evidence, and that's fine. We knew that you were going to be a reality denier. We knew
the wall is further away than she is. The wall
can I
is
explain?
Behind the circular perspective.
Can anybody hear me?
Perspective, but we can still see the wall.
Yeah,
can
go ahead,
anybody hear
Jason,
me?
explain it.
We hear you.
Yeah,
Jay.
I'm the one that made the video, right?
Yeah, let's listen to you.
Oh, thank you. I finally got to talk. So the camera is up on a tripod for the picture that's on the left. And this was from the footage, the position that she was standing in, the look that she had with that image on the wall right there. I loved that shot. And from the footage where the camera is on the floor, I chose another shot of her that I liked, and I put the two images side by side for us to compare.
Have they got different zoom values or something?
No.
What? Then what? Like Tom said, why is she bigger in that one? Or is it cropped?
Cropped. Yeah,
cropped.
when I
Okay,
put the
okay.
two images together.
But do you? So in the left portion, the camera's on top of your tripod. Let's say, I don't know, 3.5, 4 foot high. So you have a certain angle between your camera, and the floor. There's an angle to her feet, isn't there? However many degrees. Let's say it's 5 degrees. So the floor to her shoes back up to the camera is about 5 degrees. With the image on the right, your camera is on the floor. Let's say it's 1 degree. Yeah, that triangle is 1 degree now. So you've changed the path of the light. That light is getting refracted and bounced around. Snell's law is changes in density in the air and temperature.
What I've done is I've made the circle of sight smaller by putting the camera on the ground. That's the reason why her feet start to look like she's disappearing into nothingness as she's walking away halfway down the mall. Now, the thing is there is a live stream of this entire thing that you can check. You can see the actual footage from the live stream. It's all available. And yeah, it's just, you can test this anywhere. Go to a large factory and have somebody walk away from you on a perfectly flat floor, and you're going to see them disappear from the bottom up on a perfectly flat plane. We're just pointing out that this is how perspective works on flat surfaces.
But no explanation of why that black line behind her feet, why it's all distorted on the rightmost image then. Why would it distort? It hasn't changed its distance away from you, so why is it distorted?
Because it's beyond, this is something that's beyond the circle of sight here, that there is a haze that happens right there. Now, I know that you want to look at some zoomed in footage of like the sun at the horizon. So we're outside of a building and you're talking about the reflection at different elevations. We're going to get to that kind of stuff, but I wanted to just bring this up. I feel like time-wise, we're sort of going to have to jump ahead.
Yeah. Also, time's getting on for me because obviously we did have delays at the beginning, and I'm going to have to get on in a not too long a time.
All right. So let's be judicious with our time, and I want to show you some clouds behind the sun and stuff flying.
Can you show us your
right
best
now.
evidences your best evidences to debunk the globe, or your best evidences to show the Earth is flat?
There's too many. We've just begun.
I know, but unfortunately, I've only got so long. So I'm asking, can you move on to your strongest?
He was going into the clouds behind the sun. Go into the section that you were prepared to go into. There's obviously going to be some super chat questions, right, TJump, or are you not getting any?
Oh yeah, I got a few.
Okay, but Jason does want to go into the clouds behind the sun. I believe that's where he was going. You have to re-screen share the motion program. Our best proofs of the Earth being flat is the sea level itself. We've been showing you throughout the whole podcast how perspective works, how the different rotations and motions do debunk the heliocentric model. But we're not here to prove to you that the Earth is flat. We're here to show you that your heliocentric model, including the sky and everything else that you witness, is very wrong. And you were sold a lie by Kabbalistic mystics who didn't believe in what you think you believe in. They did it so that you could become I don't know if both of you, if Mr. Sensible is an
What's the argument?
But Jason, continue. I was just talking while you got prepared.
Yeah, so this is some footage that Ronnie took. We were actually with friends, so you're going to hear some people talking in the background about what it is that we are filming here. Now, the thing that the reason why I have it in here is because I can put on an array of different filters where we can see this in a whole bunch of different ways. And so clouds behind the sun is a real thing that we've been proving for a long time. Take a look at this footage.
Still a fucking ocean. And here we go.
So this is just the raw footage without any sort of filters
There it is
applied
on the
to it.
P1000. There it is in
Now
the regular camera.
We're gonna add a little-
your regular cell.
little emboss filter.
But here you
I'm
go.
going to add a little
Clouds behind the sun. There's
indent.
clouds in front of at the bottom here. Right?
can
There's
adjust
clouds
this.
clearly around it behind it. Everybody can see.
So you're basically saying that sun is within the clouds,
Yep,
Jason.
that's what they're saying.
Yes.
Well, let's talk
Yes.
about the emboss filter. What it's doing, Jason.
Well,
Well, it's working on the imagery he recorded, but you'd have seen that with the naked eye too. All
did.
you've got
We
is
did.
some bits in that still there at about the 5 o'clock position. You can see cloud in front of the sun because it's thicker cloud. Any cloud that any cloud that's
That is hilarious.
any cloud that's across the rest is obviously thinner, and so the sun is shining straight through it.
So you
This is
understand
not a
that thinner
difficult
clouds
concept.
the thinner clouds are showing up in the emboss filter that he's applied here. It has nothing to do with the thickness of the clouds. It has to do with the perception of the depth of the clouds inside the shot.
We came prepared for you to make that claim. So
It's the pride
let's.
of
Well, I mean,
likes
what would
museum.
follow if your
night
claim
walk.
was correct? What would follow is that sun is literally within the clouds.
Yes,
So
that's
they're
what we're
only going to
saying.
be a few kilometers up.
A couple miles.
No.
Yeah, that's
A couple. So your sun is within a couple of miles of the surface of the Earth. In which case, how can you see it across half of the Earth at the same time? This is ridiculous.
well, you
No,
live in
we-
a virtual reality, and the way that it works is depending on your latitude and longitude, you'll have the sun in a certain angle at a certain time every day.
Right, so here's another piece of
Wait.
evidence.
So I just want to jump in here. So if I take a bunch of pieces of tape and I put one piece of tape, one layer of tape over the entire, let's say
Again, we're
plane-
looking at observations, T-Jump, and you're bringing
Ronnie,
up
shush,
nonsensical
shush,
thought
shush,
experiments
shush.
again.
Get someone else's turn. Shush.
We're
So
not
if I
getting
take
anything.
Tape and put it over like a piece of glass, and I hold it up to the sun, and then to put another piece of tape somewhere in the middle. That one piece of tape will be darker. Like it'll seem like the sun's coming through all of the top pieces of tape because they're light, the same consistency. But the bottom piece of tape that has two layers, it'll be darker, and so it'll seem as if the sun is behind the first one but in front of the second one because of the consistency of the brightness. But the more layers of tape you add, the darker it will be, even though the sun is still behind all of the pieces of tape. So I can generate that exact same image with tape on
No,
a
you
piece of
can't.
glass.
Continue, Jason. That's just nonsensical
no,
reality. You're just talking
You
nonsense.
can do
Go ahead.
this. You can do this.
If I could only speak. All right, so I came prepared for you guys to say that it was the brightness of the sun.
Yeah.
So-
Okay.
We're going to take a look at some of this footage here. Now I can show it to you, original style like this first. This is the way you'll see it on YouTube. So notice this.
And here we go.
I got to turn off the audio in this other clip now.
Yeah, but Jason, we're not denying what it looks like.
No,
That image, that's still
great.
there. Yeah, that's what
great.
it looks like. It's an optical illusion.
No, you're going to
No,
tell me that my
because-
observations are illusions, and you want me to go to his tape over your phone.
Oh, sorry, it was
experiment
your
and nonsense over
film.
your-
Sorry, it's your film, Ronnie. Yeah.
This one here is from Flat Earth Photography. Mine was
Oh,
the
okay.
original. But what we
Okay.
want you to pay attention to is how the sun is literally slicing this cloud here. Show them how it comes out the other side of the sun.
Yeah.
Slicing
So did you?
the
Let's look at it. Let's
yes.
look at
Did
it.
you see it at the
A
beginning?
little bit.
All right. Watch this cloud here.
The little tiny cloud that's not being obscured by the brightness of the sun.
Yeah.
The darker ones are definitely staying in front of. Watch how it splits like that. Jason's got.
All right. This is just without filters on it. We can add filters after this.
Don't
I just wanted you to be. I just
What's the
want you to
problem
become
here?
familiar with it.
Watch how the backside comes out from behind there. You can go back a frame. You can see how it was split in half.
No. So if you have a really bright light and you shine it over something, they'll think.
So why is it not blowing out the rest of the clouds?
Shush, Ronnie. So if you have a really bright light and you show it over something that has multiple different layers of density, the lower layers of density will disappear first and reappear first. This is not hard.
We're looking at multiple densities. Some of the wispier clouds are behind the sun, you guys. Open your eyes. We're showing you that the sun is
like-
literally slicing that cloud. It's observable, repeatable, and you can go out and investigate this yourself. We have guys that have joined on, that have watched our programs, that have gone out and bought these tools. David Pack, he joined up due to reality check.
Wait.
You can
So
get
I
us
just
on
wanna
Telegram, and
clarify.
he's
So-
going out and he's verifying that clouds are definitely behind, in front of, and being sliced by the moon. And he's just somebody that showed up not even that long ago. So again, these are things that we want people to test.
So again, you can just Google creating art with tape and scalpel, and you can recreate this on a piece of glass. You can cause the
Mick West
exact
did it
same
with a film
thing.
strip, and he had to be taken
Ronnie,
down because
Ronnie. So you can create this exact same footage by just using layered tape on a piece of glass.
do you know how retarded that sounds,
Ronnie,
T-Jump?
Ronnie,
You're talking
Ronnie,
nonsense. We're looking at an
Ronnie.
actual observable, repeatable evidence, and you're telling me you want me to put tape on my... You are sounding retarded, bro. I'm just going to be quiet. Go ahead.
So if you can create this same phenomenon on a single plane of glass, which you know the sun is behind all of the glass, so it can't be behind the tape on
You
the
can't
glass. You can
go
prove
ahead
that
and do
this
it
is
and
very
send me the
easy to
video, and
replicate.
we'll come on stream and we'll look at your nonsense putting tape on glasses. We're looking at actual evidence. Like we said, we're going to show you
Oh my
real
God.
evidence.
Oh my God.
Let's see if you can do this with tape here.
Sure.
All right. So now we're going to show something flying through the sun. All right,
flying
let's see.
through the sun.
Go on then.
Yes.
I'd like to see this. Let's go.
So here, yes, finally. I gotta check a couple filters here. This.
Turn off all the filters.
Yes, I'm going to. I gotta move my camera so I can see where.
But just while he's fiddling with that, Ronnie, this business of the clouds is only two.
It's not business.
Hold up, please do me the courtesy, please. There's only two possibilities. Either it's an optical illusion, as Tom and myself are saying, or that sun really is amongst the clouds. Those are the only two possibilities, aren't they?
Yes.
Yes.
You got
In
it.
which case, if you're talking about the sun only being a few thousand feet high, right, then just geometrically, it cannot be dawn on one side of the earth, midday.
Well, the scriptures
somewhere
say,
else,
so
and
the sun sets,
just-
so too he rises, and he
You're gonna have
rests not throughout his circuit. And yes, everybody, I explained to you, I'll say it again, I'll get back to you, Jason. Sun's rise and set angles are dependent on where you are, east or west, on our four squared rectangle map.
You're gonna have to
Continue on.
come back because we actually have it all modeled out already, showing the rise set angles within a person's circle of sight. We've got it to 100th of a degree per second. So this footage right here, a lot of people are familiar with this in flat Earth because it came from
Was it
a
Shazwar?
popular fake flat earther
Play
and
it for the video.
Shazwar Bug Tea. All right, so in the background here, you're going to see something come, a light come on. Just watch there. It comes through and it shoots out there. All right,
Right.
all right. So I've got better footage of it than this, but I just
What is
wanted
it
to show this
supposed to be?
because this had millions of views on it, and so the premise is that we get planes flying through the sun. So let me go to
Through
my
it.
footage of this quick.
Interacting with the luminary itself.
Did anyone on the plane notice the fact that they've
So
been
great question.
flying through-
So what we have here is the same principle that is put into play with everything that's in the sky. All luminaries, rainbows, stars, sun and moon, all are fixed to your observable position. Depending on your elevation is how far or close the sun and moon are. So the person in the plane is 3 miles away from us and they see the sun 3 miles further from them. But from our vantage point inside the simulation / virtual reality is the better way to put it. This is how we observe it. And this is evidence that we're putting forth.
So
what
we had a
you've got
super
is
chat
exactly
specifically
s-
about this. Super chat from Andres Elf. Why have no airplanes crashed into the sun? Because if it's in the
I
clouds,
just explained it. I just explained it for you. Get a pen. I'll say it again. So the plane, the sun, the moon, the stars, and you know how they say you'll never get to the end of a rainbow? It's because the rainbow is actually locked to your position equidistantly. The closer you move to the rainbow continues to move further away due to the
Do you know
fact
why,
that it's
Ronnie?
a
then
subsolar
how is
point.
it in the clouds?
I know why. I'm teaching you the truth of
You're
it.
teaching us
So the
nothing.
person,
the reason the rainbow
but it's because
appears
you're
to
not
move-
opening your brain enough. If the plane has a fixed position to the sun will continue to stay the fixed distance away from the plane. But what we're observing in the virtual reality is basically how it breaks down. These are clues that were left behind for us to investigate and discover.
So how is it in the clouds? Because if it's literally in the clouds, it can't be receding infinitely when you go to it.
at the same time.
All
I just
right.
explained it.
Can you guys?
No,
Magic.
Can you guys
computer-
see?
Computer.
Is anybody
matrix?
listening? Anybody listening?
Yes.
All right, we're going to take a look at an airplane that's coming in. This is footage that I got. I barely get it on the left side entering the sun, but I do pan up and we get to see it coming out real cleanly. And this is without the filters being applied. So you saw a little bit of a streak right there. Then I pan up and it comes out through the other side. Now, at this point right here, is there anybody that's going to deny that this plane is interacting with the sun?
me.
Yes.
So you're going to
Unless
say
that plane's about 93 million miles away, of course, and very, very large.
So you're going to say that you don't see
And
this
heat-proof.
right here.
Yes. No, what you can see is you can see the light reflecting on off the exhaust or contrail that the plane's leaving behind. The reason you couldn't see the plane when it was right in front of the sun is there's a bloody great light behind it, blinding you.
No, we're gonna prove you wrong right now.
So
we're
like
gonna
if I
back it
take
up.
if I take a mirror or a sheet and I
It's-
put it above the sun, retrospective, the sun will reflect off the mirror sheet and hit my eye and it'll appear brighter because more of the light is hitting the sheet and
Well,
reflecting
I
back.
mean,
So like
what does
the
that even mean,
exhaust of the
T-Jump?
plane
What are
acts
you?
like a
I don't
mirror.
understand. It's not reality again. You're asking me to imagine some crazy thought. Please explain to me what you're trying to say.
The plane literally comes out through the disk of the sun. The other one did too.
Do flashlights reflect off of clouds? Can you point a
I
flashlight
don't
at a
think
cloud
so. I don't
and see
think
the
we
color?
could reflect. I don't know. I don't think so.
Do
I
you,
don't
do
know.
you see the flashlight hitting the cloud? Like, do you see the light that hits the cloud?
I don't have a flashlight that can light up clouds.
Jaronism might have that one.
Oh my God! Like really?
The
Really?
one he
You
used to prove the curvature of the earth, right? It was a
can't-
flashlight
pretty
experiment.
easy to understand.
But we are
kiddo.
showing
Like,
you guys things to really
kiddo,
check out your
kiddo,
reality.
kiddo.
Don't
Like,
you?
you can point a flashlight at a cloud and it lights up, right? It illuminates the cloud. Light reflects
I
off
mean,
of
you
the
think you
cloud.
bounced a photon off the moon, so I don't know. Do you have any evidence or data to back up that claim that you made with your debate with Jason that you bounced a photon off the moon and you received a signal back?
Bounced a photon off the moon. You mean a
Yeah,
radio
you
wave?
said in your debate that you bounced a photon off the moon.
You mean
Correct or incorrect?
Radio waves, like a photon.
Okay,
yes,
so it was a radio
anybody
wave.
can bounce
Okay.
photons off the moon. Put a laser at it. You bounce a photon
So
off the moon.
it was a radio wave, right?
Radio waves aren't photons. I don't think.
I mean,
Are
do
they?
you
Yes,
have
they are.
data
Yes,
or
they are. They're
backup
waves of
science?
light,
Because
yeah.
most people will use that claim because they've seen it on Mythbusters. And I
What?
just wanted to see if you actually had the
Mythbusters?
data to back up how long it took for your, because if you actually had that data, it would probably give us a more local, real understanding of how far the moon actually is.
Yes,
So-
that was the point of the test. You can bounce ham radios off the moon. Yes, anybody can do that. You can do that.
But
You'll
how
buy
come
one.
you can bounce signals off of the stratosphere without, how's it getting through those Lorentz type bounce systems and not coming back to you off of just bouncing
By
off of
using
the
a longer
atmosphere?
wavelength? Because if you have longer wavelengths, they don't bounce off the stratosphere.
Okay, you answered my question. That's all I wanted to know.
Okay.
All right, so here you can clearly see when something flies in front of the sun, right? It's very obvious. Now, this is somebody else's footage, and
Is
He
this
gets a-
David Pack?
yeah, it gets a whole bunch
Shout
of. He must be near the airport. Here's one coming in right
Great
here,
shots.
and boom, you see the interaction. There was
frozen.
two.
It's
It's-
frozen.
Yeah, I see.
I'm
it frozen.
seeing a still, Jason. Maybe unscreen share and rescreen share because this is some great stuff. David Pack is new. We found him again on Reality Check Telegram. The link is in our chat. He showed up. He's got this great vantage point. Go ahead, Jason. Now we can see it.
All right, so he's near an airport. Obviously, he's got a bunch of planes flying through. One just went in here. Another one's going to come in right here. This one came out. This one came out. We're not done yet.
Now we're just
Same
seeing
thing.
it's hard to tell. We're seeing a Nikon P1000 Sunset Dallas, Texas link. Okay,
Same
there.
thing.
We've seen it go into the sun there. I saw that.
Right.
No.
It's the same thing.
It's going to come out the right side. It's gone. For some reason, it's blurry. This is right from his own channel, Jason. Why is it
Mhm.
blurry? But he's got
But
some
the-
great footage.
This is not difficult. If you're stood or someone stands in front of a car headlight at night and it's on full beam, you're not really going to see anything, are you? It's just blinding.
But he's showing planes going in front of the sun and planes coming out from behind
Yes,
it.
we can reproduce
right?
this with car lights. That's what he's saying. If you stand in
No,
front
you
of
can't
walk in
repro-
front of a car light, you'll get the
I
same
mean-
phenomenon.
There
You
we
can
go.
clearly see before the plane is even at the. Look at this. You can clearly see it interacting right here, and then it'll.
So you're
fly
saying that
through.
plane's going behind the sun?
Well, or through it. Look at.
Well, if it was behind it, suddenly for them traveling whichever direction, the sun's on the wrong side of the aircraft. Do you not think they'd notice that as well?
The sun is always projected at its azimuth and altitude and based on elevation. So the people inside this airplane would see the sun at the same heading, right, at the correct elevation, but out at their horizon.
So
I'm
you're
not
saying
really
that
sure what
we
that
see the
means.
sun in front of the plane, but the plane sees the sun behind the plane, and because of magic.
No,
No,
not because
no,
of
we didn't say
magic.
magic.
That's
But if you want to talk
so
about
you
magic,
okay? Was that
let's talk about the green flash. You guys know about the green flash?
Mr. Sensible has to know.
Yeah, it's only to do with the way lights bend in the last few seconds.
Lights
of-
bending.
Of course,
If you
light
get a fish
bends.
tank and you put sugar in it and you shoot a laser.
Yeah,
at it,
yeah,
it's
yeah.
like-
From
That's one thing you can do.
Pirates of the Caribbean, where there's the ship at the end, the green flash that we're talking about.
Yeah, there's.
Yes.
Watch the bottom
TJump
of the sun.
knows
So
too.
this is what we can actually achieve with our best best optics right now. So the
Go on,
the P1000 has 125x zoom. That's a
Can I just
3000.
pause you for 1 second, Jason. Not to argue your point, but I'd just like to point out the P1000 is not the ultimate in cameras or zoom.
No.
Not at all.
No,
it's the flat earther's camera choice, but that's about it. But carry on.
But it's a good choice because it actually has more zoom capability than most amateur telescopes, right?
And
it's
a tiny,
really
tiny CCD.
Yes, and the bigger the telescope diameter, the better the aperture, the better the low light. I understand all that, but as far as zoom is concerned, this gives us, the poor man, the ability to get in to the horizon and see what's taking place there. And you can actually see it looks like some sort of energy merge right here. All sunrises and sunsets. Reflection. Just wait.
So why is the green flash not just like what's it, rainbow, which is a refraction of light? How is this not a problem?
All right, and so once again, the sun is not so strong that we can easily easily see things in front of it, right?
If you pause there a second, Jason, yeah, that's right. The sun doesn't appear so strong. It hasn't changed its brightness. It's just shining through an awful lot more atmosphere because it's just skimming over the top of the ball.
What? I don't see any atmosphere there. What are you talking about? You're imagining
things.
Don't
see any
again.
Atmosphere.
No, I see clearly. I see the hull. I see the
clouds are
sunshade. I see the
clouds are atmosphere.
But it's traveling through more of it.
Okay. If we see Alaska from Russia, go ahead.
You're going to see on the zoom out the entire perspective. So the camera's auto exposure is what gives us this high contrast scene like this. But let's let this come on down and take a look at. This is a real sunset. It's not a David Weiss shrinking sun.
Now, where's the reflection now? Where's the reflection? Where's your reflection now?
Oh, where's the rest of the sun suddenly gone?
Where do you think it's gone, Mr. Sensible?
Well, the sun hasn't gone anywhere. What's happened is the Earth is in effect rotating away.
Rotating away? So we're falling backwards away from the sun?
You're not falling backwards.
That's what you just stated.
Just wait.
Not backwards.
Just wait. Just wait. Just wait.
There it is.
Yeah.
So
where did the sun? Where's the sun going here? Where's it going? Why don't we see the sun curving around the backside of the Earth as you just stated? That we're falling backwards, steering west. We're falling.
The sun going behind the. Excuse me. Behind
around
the
curvature.
But you have got at that point just about the maximum amount of atmosphere you're looking at. What? You have changes in temperature, changes in density.
We see a little
refraction, which is going to twist. It's going to make it look fuzzy.
And this is happening above the refraction.
The whole thing's the same distance away. And if that sun is only a couple miles up,
there it goes. That was awesome. Where did it go? Why is if it's 90 million miles away and it's a huge ball of light and gas and fire, how come it's not still shining around the curve of the Earth here?
It is.
That's why you can still got day. That's why you still got daylight there.
We've got a little compilation.
No, daylight has nothing to do with the sun. Daylight and night were set before the sun was put into creation. That's correct. Really? Yes, you can see the daylight. Yes.
But wait, so what's the green flash? What about it? Why is it not just refraction like a rainbow? What's the problem here?
You can see these flags on buoys out at the horizon right here. Right now there is the top flag on a buoy. There's another one over here, a flag on the buoy.
Cool.
Yeah.
And this is where the sun is sitting in a green flash above the horizon.
Which is evidence of what? What's the problem here?
Mirages and distortion are
mirages.
A thing. Yes. What is a mirage if it's not?
Now you sound like the fake flat earthers. Rob Skiba and Rick Dick Hummer went to the Lake Michigan and tried to pretend that they were able to film Lake Michigan from the other side, Chicago. And mirages and refraction. Yes, we see a bit of haze and blurriness at the horizon, but we're looking above that where the sun is actually disappearing into we don't know what. We're asking you what we're looking at.
Yeah, no.
Well, how high is that camera, roughly? Do you know?
We'd have to ask David. It's probably 6 feet above the. He's got it on a tripod, right. I assume.
So how far away was that sun? Because going back to your woman in the shopping mall, she apparently lost her feet at 150 yards.
That was due to the
and yet that
vanishing
sun
point
you
of the
can
camera.
see for several miles away, apparently slowly disappearing. Anyway, I don't know why you guys are coming up with stuff with that. Why not just go up and have a look and see the shape of the Earth?
Oh, you want us to go up in a rocket? Which
Yeah,
is
we just
There's other
covered
options.
we just covered the highest altitude that has ever taken place. So high altitude balloons can get you up to, they say, 273,000 feet, and the highest rocket was able to get up to just like 300,000 feet. That is the limitation, and everything beyond that's not real. So I had talked about pressure with TJump earlier, and we went through in our most recent hangout the debunks of satellites and space travel and all that stuff based on pressure, because there's no more air up at those altitudes. We showed how the reason why the high altitude balloons break is because there's no more air pressure. The
That's right.
balloon expands
Well,
into the
there is
point
some,
that it
but
pops.
it's very, very low. Yeah.
It gets to zero at about
Zero.
150,000 feet.
And we
Well,
don't
Pete-
believe in
Pete-
we lived in a pressurized pizza dome like Nathan Oakley too. Don't be careful
No,
not
no,
to
I'm
straw
not
miss
sure-
because that's a
No, I
retarded
haven't
statement.
strawmanned you at all. I haven't strawmanned you. I just agreed that as you go to a certain height, the pressure gets lower and lower and lower
Nothing.
until it's virtually zero. It's not quite zero, but it gets to virtually zero, because even space wouldn't be zero.
Well, they say at 150,000 feet, it's like 0.0000016.
Well, I got a question for you. So you're saying, I just want to clarify something really quick. So you're saying that things disappear at the vanishing point from the bottom up. That means that, and the higher they are, the further away the vanishing point is, right? And
Yep.
so if a plane and sun are both like far away, and that the sun is like going down the atmosphere, how could a plane pass behind the sun if it's a further away vanishing point while the sun is
The vanishing
disappearing
point is
behind the vanishing
perspective
point?
to the observer. That's what we explained. So the vanishing point of the person on the plane, the sun is still 3 miles away. But the vantage point from the person on the ground with the sun in the right position would put the plane interacting with the sun, and that's what we witness.
That Nikon ever made.
Oh,
How far we can see?
I'm going to have to go very shortly. May I present rather a neat bit of evidence? This is an experiment that I did. I think I mentioned it when we met at the top of the stream, Jason.
Yeah, you can share.
Okay, thank you. I'd like to show you a photograph first and see what you make of. Where is it? Come on. Is it? I'm not sure which one it's showing. What's that showing? Is it showing
A black screen right now.
It's
Double click. Oh no. There we
here
go.
it comes.
We're good.
Yeah. So what can you see? You can see two lines and a curve of the horizon. Yeah.
Yep.
Is that what you can see? Whether you agree with it or not, is that what you can see?
Is this
Yeah.
from a satellite?
No,
This is from a,
says like 30,000 feet, right? It says 35,000.
Well, 35,162 meters, about 200 meters, or actually about 400 meters. No, about 3,000 meters. Beg your pardon, lower than Felix Baumgartner. This shot.
That
So-
wasn't real.
Yeah, that was green screened, and he jumped into a
Yeah,
foam
let's
ball
leave-
pit.
Foam ball.
Well, let's
pit.
leave Baumgartner out of it. I was just giving you
That's
an idea.
fake.
I'm just giving you an idea of the height. This is 35 kilometers high. Can you not see a curve there?
Yeah, the image itself has obviously been squished, and this is something that Red's Rhetoric tried to do. He tried to take a picture of a flat horizon, and then he tried to squish it and show you,
Hold
look,
on.
measure up to the line.
Ronnie, what makes you think this is squished?
Well, right now we're only seeing the image itself is truncated. We're not seeing the complete fullness of the image. Well, I can tell you that right now.
Okay, let me just have a quick look, see what you're seeing to make sure.
Where did we get this? This is from NASA?
No, hold on. I'm just trying to have a look at the stream
You
to
just
see
gotta
if I
hit the
can
live
see
button.
if
Live.
the
Hit the
whole.
live button. There you go. Live.
Oh right, it's still showing stuff about your son on mine. No, that is not. That is not.
Oh,
that
this is the image?
NASA. Sorry.
The image is truncated. So you're basically proposing that this is you're showing us your evidence of curvature.
This is a picture from 35 kilometers showing curvature, right?
I don't think it's coming through right now. You might have to reshare it.
Yeah, something's truncated.
Okay, let's try that then. New share, or do I have to stop share?
Yeah,
Okay.
stop and reshare.
Has that come through now?
No, it's still frozen.
No.
Oh,
Okay.
There
I'll
you go.
actually
Now you're
stop
about to
it.
refresh.
Right. Share. Hopefully that's coming up.
Now it's
we can
clear.
see it.
Yeah. So that is showing the curve of the Earth at a view of 35 kilometers. Okay, this, now you can see there's a grid over it with a curved line. That's the predicted curve, mathematically, the predicted curve for a height of 39 kilometers. Now, this weather balloon did not quite reach that the height we wanted, with regard to getting a good shot, able to see what was what was there to see. Now, you said it's squished. That is not squished. Those two lines here is still from a video. Just trying to...
Also, what you have is when a camera tilts up and down, up in the air, what we do have is sometimes concave Earth and sometimes sphere Earth. So you've just taken an image of, while it was pointed at an angle away from the horizon, curving it due to the lens of the camera.
Okay. The answer is no. Because there's three main types of lenses. You get fisheye lenses, which are the ones where people hold a selfie stick and it looks like they're stood on a tiny ball. Forget that. You've got wide angle lenses, which do distort like that. And as you move up and down, you'll get convex and concave.
And the good one.
Here is an image of Mage. This is the weather balloon.
A rectilineated lens is the correct answer. You didn't give us that information. And if it was a rectilineated, you will be the only person that has proof of curvature. And if people want to let the cognitive dissonance believe that you just showed the curve,
I'm trying to present the evidence. That camera, you can see the white sort of bit of pipe in the middle. The camera is mounted just below that, pointing towards the left. On the left, you can see two strings. Those are taut, spring-loaded strings. So they are always straight. There they are across the image. So if the image got distorted by me through some dodgy purposes or dodgy method, the strings would be distorted. In fact, there is a very, very slight bowing downwards of the lower string because of barrel distortion, which you get even in a rectilinear lens. But the curve is going the other way. You don't get the convex or concave distortion across the middle of the lens.
You've thought it all with that graphic, huh? Jason, what do you think of this curvature Earth evidence? Is this repeatable, verifiable? Can I go out and test this myself, Mr. Sensible? And our audience, we've shared in the beginning of this that my premise was that you can go out and test everything that Jason say.
There is me.
You're telling me. Okay,
there is me launching it. If my video kicks in, it's for some reason it's buffering a bit. But there is me.
So you conducted this experiment yourself. Do you have a verified other show me somebody else that is not connected to you with the same clip and the same experiment. Right? Let's see more.
Yeah, I'm sorry, I don't know.
But your balloon went 35 kilometers up, and you're touting this as proof of curvature of the Earth's rotundity.
Well,
because of these two tightening strings that you have here.
Hold on, look. Here are the three cameras. There's an upward-facing balloon camera, which is wide camera. There's a rear-facing wide camera, so you can see that gets distorted left, right, and center. But on the main screen, that's the rectilinear lens with two spring-loaded strings. And in fact, we were talking about the balloon bursting. Have a look at this. This is a thing of beauty. That is the
nice
hydrogen balloon as it's bursting, and it bursts at the speed of sound. So yeah, I sent that up. I took that imagery.
Yeah, we just covered this topic, and yeah, great job.
So it doesn't quite match the video that we saw.
The thing that
doesn't match the
video. What camera were you using?
For
the rectilineated.
Yeah, it was a non-distorting camera. I can't remember the name off the top of my head, but on my channel is the Mage video. All the cameras are listed. Okay.
Yeah, so what do you say is the natural view of a human? How many millimeter equivalent would you say?
I don't quite know what you mean by that. But look,
if you were
it is.
Nice.
Here it is, and I've definitely got buffering here. I'm getting internet problems. Can you still hear me?
Yep, we can hear you.
Okay, my picture's frozen, but there's the two spring-loaded strings. There's the camera mounting was looking through it. So if that horizon is a curve in between there, if I had got that curve by distorting it, then these strings would have been distorted as well.
You know how
They're
easy
not.
you can crop in, chroma key in 2 lines across the screen?
He hacked it.
Like,
He
you know how
hacked the
easy it is? I
picture.
could show you the
So-
ISS transiting
Yeah,
the
but then
sun and the moon and the stars,
you
and you
have
would
got-
have no idea I could put the 2 strings there. You know how
No.
nonsensical.
The no
Okay,
argument.
but
That's
hey,
just
at least you
denial.
did the
That's
balloon thing,
just
and how were
Ronnie.
you able to track it? I find it amazing. Would I have done anything I've ever
Yeah.
shot up into the sky? I lost. You know, did you have a
Yeah.
tracker? But
Yeah,
anyways,
we
Jason,
had
do you have more?
Let me tell you, we had 2 GPS trackers. They broadcast their location. High altitude balloon enthusiasts around the country track it, upload to a central server. We download, so we got the current location. It traveled one direction for so many miles, back another direction for so many miles. It landed about 40 miles from the start point. Okay, the flight time was about 2 3/4 hours. Now, when we were at ground level, the only tracking station that could pick it up was us. When we were at the maximum height, it could be tracked from 400 miles away. We were seeing further and further around the curve, something
think-
called the radio horizon.
I think it's great that you did the experiment. I find it fishy that you don't remember the camera, but you remember that the tinsel
Oh, I can find
strength
out
of
for
the.
you, right? I can find
But
out
continue.
for you right
Jason
now.
wants to go on to. Let's go on to the sun's locality
I bet you
again.
do. I bet you do. And you did
Let's
say
get on. Let's move on.
You
Yeah.
think that picture of somehow proves that the Earth is a curve, and I find that
Yes.
hilarious. So
Yes, it does.
It
I mean,
was
the kid
there
is a
in
literal
front of your
camera.
eyes. I filmed it with a video camera. You know,
Yeah.
a little. It wasn't a GoPro, or it might be a GoPro, but it was one that did not have the wide-angle lens. Otherwise,
Okay.
the strings would have been distorted. They weren't. You can't have it both ways. Either the lens.
yeah,
is
you know what I
causing
said
the
to your audience:
distortion-
if they want to allow cognitive dissonance to allow them to believe they live on a sphere because of that one image that you just showed us, go ahead. Let's move on. Jason's
No,
got
I've
more.
got a full video, including a launch to landing, and I even leave the film running for about 30 minutes while it's upside down in a field until I pick it up. So you can see me let go of it. You can see it go up. You can see it seeing across 400 miles. You can see it come down. You see it land, and me walk up and pick it up. That's an uncut video footage. You can deny what you
NASA does a
see.
great job too of it. Jason's got some really interesting stuff. That you
Unfortunately, I'm
gotta
not
look at.
connected to NASA.
That's great.
I think I just want to bring up that was a really great point where he brought up the video. Ronnie said it was distorted, and then Mr. Sensible showed that there were literally 2 physical strings in front of the camera. So if it was distorted, the strings would have been distorted. Disproving.
All you
Ron's
have to do
argument
is
definitively
chroma
that
key
it
out the
was not
strings and
distorted.
paste them back on top of the image.
But
I
he
could do
did
it
say
in
it was
seconds.
If you watch the actual video, Ronnie, you can see the strings. You can see as the thing turns around because it's dangling
I
from the
understand.
balloon. You can see the shadows pass along the strings.
So in that,
it's real.
in that very short distance, we were able to see that the bottom string did have a curve to it. You called it barrel distortion. So
Yeah.
that right there is going to be amplified at a larger distance. If we're
Yes,
seeing
but
that much,
opposite
if we're seeing that
direction.
much,
It's the opposite direction. Thank you, Tom. It's the opposite
Which happens
direction.
depending on
Do you
the
not
angle
get
of the
that?
balloon. Why don't you have, do you have full video footage of that happening constantly, that same sphere? Or did you just take a screenshot? But we need to move on to something more
Yes, he has the
interesting
full
than that.
video. The full video is available.
Yes, a 2.5
And
hour
we'll
uncut-
look at it, and if people want to take their cognitive dissonance and believe that they live on a sphere because of your experiment,
but-
go right ahead.
Ronnie,
but
Ronnie,
the
being
rest
wrong
of our
about something
presentation has
is
debunked
okay.
everything.
Holding an opinion or having an idea of how something is okay, but just saying "nuh-uh" in the face of evidence is not okay.
Your evidence is very circumstantial. We're going to continue on to more actual, repeatable, observable things that we can all do. I don't need to have a
That's
Vatican
repeatable,
telescope.
observable.
Or
It
you
was
don't even
caught by
remember what
3
kind of
cameras
camera. You're admitting
from
that there was
beginning to end,
distortion in the
and
image.
nobody has been able to debunk it.
Debunk
all right, so
what?
here,
Your picture
here we
of
have
Curvature?
some footage of a sun in a scene with what some people call chemtrails, right? then
Jason,
we have-
just
and then we
sorry,
have the
just before you
shadows
get into
behind.
no, not to argue what you're talking about. Just let you know, after this one, I'm going to have to go. Okay,
All right. All right.
and I would like to carry this on some other time.
And I'll
'cause I've
make sure to
enjoyed it.
watch the rest of your video.
Yeah, okay. So just to let you know then, Ronnie, I've got 2 channels, Mr. Baldy Sensible Cats and Mr. Sensible Live. That video is on both. It's called Mage, What Shape is the Earth?
Your
Mage.
teammate, Conspiracy Cats, donated his channel to you? Is that why it's called
He
Cats?
did actually, yes.
Wow, that's great. I can't believe I knew that. Moving on.
All right, so here we have a scene with the sun, and we have these chemtrail-y looking things, and then a shadow on the clouds behind that. So this is footage where it pans around. So this shadow, the shadows always point to the location of the light source, right?
Sure. Yes.
Yeah, that's an that isn't. I'll give you that. That's a more interesting picture than the airplanes flying through the sun or airplanes in clouds. That's more interesting.
Well, there's so many different ways that we can actually show and prove this, but it's hard when there's all these opposing opinions and we don't get the opportunity to actually go through all the evidence and analyze it. But so what we're doing right now is just showing the things that show the locality of the sun. Right? In this case, we know. Here's one example of it. I'll show you another example. It's all over the place. Where the shadows are locating the sun in a person's circle of sight, where the shadows are being cast up on the bottom of clouds.
Yep.
We see this all over the place.
And where's the sun? Look, it's near. The sun is just about to drop below the horizon. So yeah, the shadows cast upwards.
The wrong way. Let's go back.
It's not
here.
wrong. Why is that wrong?
Yeah.
You're showing
because the shadows being cast backwards from this X right here from the sun. The shadows being cast backwards on the wall, making the sun local in the circle of sight right here.
If the sun was 90 million miles away, you could never have the shadow on that side of the chemtrail.
Yes, you could.
No.
You say that.
They're called contrail shadows. Like there's a name for
this. What you guys
this.
need to do is you need to go to your local hardware store and see if they stock any Ds, because you're going to need 3 of them.
I don't know.
Explain to us. Tell us the 3Ds. I know you want to.
Yeah, 3-dimensional. You're finding it difficult to envisage things in 3D. That's why you have such a problem with the whole thing
I am a builder that uses 3D modeling to sell my work. I 3D model all of it. I know how I see things 3-dimensionally that other people can't even comprehend. I can look at a plan that's on 2-dimensional sheets, and I can visualize the entire thing 3D. I can tell you which light's going to cast at what time of the year, just in my head. I understand 3D, and because I understand 3D, I understand that the sun is in front of this cross right here because the shadow is being cast behind it.
Well, there's actually, so this is a well-known phenomenon. You can actually Google it, of contrail shadows and how they're formed. It's pretty easy to explain in multiple different ways. There's multiple ways to do it.
Tell us what Snopes says, please. Tell everybody in the audience what Snopes says. How do they debunk this?
Who's Snopes?
It's a debunk nonsense group. I'm just being funny.
Oh.
But really what we're looking at is the locality of the sun. The shadows are showing its anti-position, right? Pointing towards it.
So one shadows reflect, or light reflects off of clouds, remember? So you can actually create a shadow by having the light reflect off of the cloud, hit the chemtrail thingy, chemtrail, and then hit
the shadow is above the cloud, though. The sun must be below this. And if the sun was 90 million miles away, it would never be below this plane ever.
No. So
it's
there's a plane,
impossible.
cloud is here, plane is here, chemtrail is here, chemtrail.
And where's your sun in your heliocentric model? 90 million miles away.
More clouds here. Clouds here.
If we were to do it scale, if you were saying where the clouds were, the sun would have to be in England, away from you, TJump, if you're in Dallas.
What?
If we're trying to make a scale of what you're trying to draw in your world.
Have you noticed these pictures with the shadows supposedly in the wrong place? The sun is always approaching the horizon.
Because it's lower than the plane at that moment. Yes. You've noticed a great observation that is absolutely what's taking place right there.
Yeah.
Now answer
go on,
this
because then I'm going to have to go, I'm afraid, guys. Go on.
You said that just
Thanks for coming on. Appreciate it.
Into the chat.
We've got an echo.
Literally.
I don't know what happened there.
No.
All right. So here's
the video I took. As you can see,
here's one more example.
Matt
Long, he had a P900. He's filming out, and the sun is actually coming up through the cloud layer before the horizon. And
no, the horizon is where that line is across.
Yeah, you don't see
the partial disc.
No,
close your eyes, Mr. Sensible. You don't see it.
This is the horizon. Yes, the horizon's back here. Just wait.
I know it's hard to understand, but we said you were going to be reality deniers. It's fine. We're just trying to broaden your horizons.
You can clearly see when he zooms back in that the sun is in front of the horizon. That in and out move.
So now we got this. Now we got the sun coming out of the sea. So it's going through the clouds. It's dunking itself in the sea.
It's just clouds. There's no sea there.
We've got all the footage. We can show it coming up out of the ground.
Trees behind it.
This is popular footage that a lot of people know.
And this one actually debunks Eric Dubay, because Dubay teaches that the flat Earth is a pizza pressurized dome and that the sun is always 3,000 miles up. What Jason was showing here is that the sun is actually local and goes way below the clouds. Those clouds aren't 3,000 miles high.
Okay, no, that's a brilliant shot, and I can never remember where to get that from. That shows you that if you've got the Earth, you've got your plane up here, the sun's here shining up from underneath the clouds. You have just busted the flat Earth. Thank you.
No, we haven't.
No, this is actually predicted in the flat Earth that we share. Yes.
Oh, really?
Yes.
I'd like to know how the path of light can travel to come up from.
You're gonna have to watch the video.
We showed you.
You're gonna have to come back.
Unreal.
Rises from the east, sets in the west, right?
Guys, I am going to have to leave now. I'm going to say thank you very much, Ronnie and Jason, for hosting, because it has been fun, and thank you for Tom for being my or allowing me to be your team tag mate today. Really
Thanks for coming on. Really appreciate it.
No worries, no worries. Guys, I'll try and watch the rest later. And if you are going to do a part 2, I'd be up for that too.
Sounds good.
Cool.
Thanks for
Sounds good.
joining. And
so if I could just give a final shout out
Yes.
to myself. As I said earlier, I've got 2 channels, Mr. Baldy Sensible Cats with a Z, which is where I've got videos, and Mr. Sensible Live, where I've got some of my older videos, and I've got live streams and things like that. Please check out my Mage video, where there's several versions of the video. There's one where it's edited down to 45 minutes and explains everything and shows the results, but there is also an uncut film from both the balloon camera and an uncut film from launch to landing from the other cameras as well. And I would like people to come back to me and try and debunk it. I really would, because several people have tried, and only one person, I'll give a shout out to him, Brian's Logic, came up with one problem with it. The temperature readings were a couple degrees too high, which I acknowledged. But other than that, no one's managed to debunk it. So I'm going to say thank you very much, everyone, and thanks for all the viewers. Good night.
See you.
all right, TJump, do you have any questions that you would like to go through?
We got about 8 questions, 8 super chats.
I have some more memes to run through real quick while he gets the super chats
memes are
and
great.
questions.
Memes are great for views.
Let me show a couple, Jay. Can we?
Yeah.
Yeah. If I'll take the screen share, I'll show a couple more memes here before we move on to the super chats. So these ones are pretty good. I don't know who believes in the wrong screen share. Let me stop.
Still
I'll let you
trying to
point
leave here.
God damn.
I got to screen share what is it that I want to screen share again? Yeah, my Final Cut. So check this out. Do you guys know or believe in the dinosaurs? Did you know that Sir Richard Owen, who created the term dinosaur, wanted to prove evolution to be true? He knew that many in the scientific community embraced that same goal as him. So he was broke, desperate to succeed. And after his invention of the quote dinosaur in 1842, amazingly, the first dinosaur discovery happened in 1858. Did you know that this is where your dinosaur story comes from, TJump?
I don't believe that's true. No.
I'm just reading to you from the evidence. Moving on here. This is what atheists be like.
First
this is my
dinosaur was discovered
grandfather.
First dinosaur was discovered in 1677 by Robert Plot.
Oh, so this is all incorrect, you're telling me?
Yes, your meme is not factually correct. Surprising, I know. I know like all facts on the internet are true, but typically memes not.
Okay, so we'll do the back check and we'll you send me who you think it was and your evidence.
Robert
was the
Plot,
first one.
P-L-O-T, is credited with discovering the first dinosaur bone.
Okay. The first dinosaur bone.
Yep.
Before the theory and term of dinosaur was even invented. Okay,
Right, so
good
you can
one.
discover
Moving on
things
here. This
like
is
appendicitis. People died from appendicitis before it had the name appendicitis because
sure.
things can
Okay.
happen before we name them.
Yeah,
Yes.
yeah, they found some big bones. So this one says atheists be like, this is my grandfather, right? I don't know how you guys believe it. And for anybody that needs to know, you need to hear this. Cartoons are not scientific evidence. This is not real. What you're seeing on the screen, for due to copyright and violations of certain things, I won't say what this is. This is a cartoon. This is a cartoon.
We actually, just to clarify, we have actual pictures of COVID virus. Like we have.
We don't
pictures
even
from an
want to
electron
talk about
microscope.
that. If you say those words, we're going to get censored now, like we already are. Did you
I-
know
I-
that
I discuss COVID all the time, so it doesn't normally happen. Just by saying those
scientism,
words.
right? 90 degrees times 4 equals 360. So a 360 is a square, right? Here, let's go into your actual globe Earth proofs that your partner there should have brought up. There's a curve, but you're never going to see it. There's a spin, but hey, you're never going to feel it.
One sec. There is a curve, and you will see it at 35,000 feet.
Oh yeah, right. Your one friend who's got he forgot the camera that he was going to use, and not only that, showed us distortion. But there's a spin.
There
but
is
hey,
a
you're
spin,
never going to feel it,
and you will feel it. Or I don't know if we can feel it, but we can see it with the Foucault pendulum, so you can see it. Yeah.
Foucault pendulum is assisted by electric power.
Nope,
they
they're
don't
not.
just perpetually
No,
move
they're
forever.
not.
TJump,
No,
that's
No,
retarded.
they're not.
What?
So Foucault pendulums use a
go back
magnet in order to reinforce.
Oh, a magnet, right? They have to be
but
plugged
not
in.
all of them have that. You can build them without those. Those are things.
So they're perpetual
museums
motion
use.
machines that you're telling me. The first perpetual
turns,
motion machine
Ronnie,
is not a Foucault pendulum.
Take turns. So
It's-
in the industrial Foucault pendulums at museums, they use an electric magnet to keep it moving, because obviously it would lose momentum and stop moving if they didn't.
Yes.
But you can just remove those and they still work fine. So
Until they
they're not
stop moving, right?
Until they stop.
And depending on which direction you started off, the Foucault pendulum is one of the stupidest things. If someone super chatted that, I'm sorry they wasted their money. There's a space, but hey, you're never going to go to it. There's a force, but hey, you're never going to be.
Been there. There's a force.
Never going to be able to
never
measure it. What,
We
Freemasons?
can measure gravity.
Right?
So we
your
can measure it.
Freemasons went to
Measure it
space.
fine.
Right. Here, before you attempt to insult flat earthers, understand that math and science disprove curvature and motion. Right? Get that into your pipes and smoke it. What other ones didn't we show? So at what point does your gravity curving water hoax take place? At what scale does this boat here then go over a giant hump of water as proclaimed?
The horizon part at the end, that's where.
The horizon, that's our vanishing point. This one here, the first rule of spacewalk, Jason knows it. Do not piss in the pool if you haven't seen this. We can do a few more here. Check this out.
You realize you can piss in the
audience.
spacesuits just fine. Like those are okay. Like they do that.
Here, for your audience who might never seen this. So the claim is that you live on a heliocentric spinning Earth, and the reason why that was born was because a Kabbalistic mystic person infiltrated into the Jesuitical order, and they brought forth this idea to worship the creation. So all heliocentrists that believe they're atheists are actually studying under the highest level of mystical Kabbalism that was ever created. The psyop of the claim is that we live on a.
You do realize that
dome.
religious people can get things right occasionally, right? That's a thing. Like Hindus predicted the age of the Earth. 4.3 billion
if
years.
they say
They're
anything
pretty
more
good.
than 6,000, they're wrong.
They're wrong,
so
right?
So you can
Yeah.
believe things religious people said without actually believing the religion, because like Newton was Christian. He got
Newton was a Python.
Newton
is a great person that you bring up. He was the one who invented this. He invented the Society of Jesus. He invented the name Jesuits, and he was a raging faggot Pythagorean Kabbalist who hated women and forged gold. And he came up with your thought experiment that now people have.
Did he? So
yeah, he was a
succeeded
gold
in the alchemy,
forger.
but, all right.
Yes, and he was also a heavy faggot Pythagorean heliocentrist. That's where your whole atheistic religion came from, was from deep mystical Kabbalism.
I think you're still confused with people can have beliefs and get things right, and you can believe the right things without believing the beliefs. Those are not the same thing. But
yeah, he still was only a geocentrist. He was not a heliocentrist at all. It's not until the 1850s that heliocentrism really got any sort of movement at all.
I never.
This one might trigger your audience.
It's irrelevant.
This one here, all these things here, we got the periscope, lighthouse, gyroscope, and sundial.
I have to go pretty soon too, so we got to move to the super chats.
None of these things can work on a globe. I'll stop sharing. Let's go to the super chats.
All right. Super Squid Hunk asks, how do they dispute the LIGO experiments proving the existence of gravitational waves?
The LIGO one where they faked the experiment and ran a test on their whole entire company that you can go and read. They faked the actual data to run a test. Is that what you're using? Whoever super chatted that, get your money back.
Yeah, so it's not faked. There's two of them.
Yeah, they actually psyoped their own employees. They came out and told the whole thing in LIGO. We've studied it all. Next question.
So I believe the refutation is nah. The nah refutation is the correct one.
I'll let Jason talk.
Defont asked, if water can't curve, what's a meniscus?
A meniscus? What does that have to do with the curving of water? That has to do with densities and types of skins that are taking place.
No, meniscus is the thin layer that wraps up around the edges. So it takes water at scale. Anytime you're dealing with a super fine amount, you can actually get a capillary action that will take water back uphill. right? So that meniscus right there is a thin film. It has to, you can actually get rid of it by adjusting its alkalinity, I believe. So
You know, it's like we ask for the real proof that
Why are we
321
going back to
million
the super
cubic
chats?
miles of
Super
water
chats.
curves around a giant sphere, and you're going to come at me with a meniscus. You're going to show me this and say that we live on a giant sphere. Do you know how retarded that is, TJump? You're retarded. Whoever super chatted you, explain to me the 320 million cubic miles of water curving on a giant spinning ball, and you're going to show me a raindrop.
What?
Next question.
Raindrop. What? That's not
What? Move on, bro. We got time. You only have so much time. Let's get,
the
where's the
explanation
more
is
super
gravity.
chats?
Gravity is why the water goes around.
Gravity.
The ball. Yes.
Okay.
Yep.
but all the butterflies and helium balloons
butterflies.
totally.
Yes. They're not affected
Not-
by the 320 million cubic miles of water that's held
We can-
down by gravity, but a firefly can just
What?
simply float up into the air.
The
So can
water
water.
can
That's what
be
water vapor does,
water
so-
can be clung to a ball like this, but the butterflies can float around.
Yeah. So if you
and-
shaped water in the shape of like a wing, and you could make it fly. Sure.
Moving on. Do you know how heavy water is? What's the net? Do we got more super chats?
Heavy water, as in like the kind that's radioactive, it's still water. But yeah.
Water
No,
is super
8
heavy
pounds
to
per
carry in a
gallon.
pail, bro. Do you work? Do you build things? Have you ever carried a pail of water?
Planes
It's
are
heavy,
heavier
bro.
than water is. Planes can fly.
Planes deal with lift and propulsion systems
Right.
to
So
fly.
if you shaped
And-
water in the shape of a plane, it could fly. Yes.
It floats in
What?
clouds right now, right?
Yeah, right,
Trillion-
Jason.
trillion-
Stop right
trillions
now.
of pounds floating water.
Stop
yeah.
it.
Clouds are also water.
With
yes,
dust
that's true.
particles accumulating into the middle
Why
of
does
the
the
atmosphere.
vanishing point only exist on the horizon? Why does it not exist in the sky when planes fly away from you?
We showed the vanishing point from a woman walking down a hallway in a mall, so it's not in the sky.
Why is it only
No.
at the horizon? Why is there never one above things above you, like birds or planes?
Yeah, because you'll see that at the distance of a plane that's coming in on the horizon, it'll actually come in above the horizon because of its elevation. Now, if it's a low flying airplane, it'll show up at the horizon in your circle of sight. But if it's flying real high, it will actually just appear from being so small that you can't see it to now being visible. It'll fly across in your circle of sight, and then it'll disappear before getting to the horizon again.
So the distance
that's
is,
what
why
we all
can't it go
witness.
up and disappear if it's going up? Why do you still always see it?
I
Like,
don't
if you-
I
understand.
if
think
there's
he's
a-
trying to
there's a-
explain why we see the belly of the plane and not the
No.
back
So
of it as it
the
flies
vanishing
around the
point is
curve.
if something gets far enough away, some distance away from you, it starts to disappear, right? But it only disappears if it's like on the ground. If it's in the air, it goes farther away. You said like the vanishing point increases the higher the thing is, or something.
Yeah, it'll actually disappear up in the sky. You just
Moon
gotta
is a
watch
great
planes
example of
come
that.
in and out of your circle of sight.
Show me some of those. I want to see a plane going straight up and disappearing.
Not straight up, it's flying horizontally through your circle of sight, but because it's traveling at its 20, 30, 40,000 feet, you won't be able to see the plane at the horizon, and you'll see it appear in the air. It's everybody witnesses it. That just go film.
Well, that's why the
Cool.
question: why is the vanishing point so much further away in the sky? Like it's infinite the higher you go, essentially.
Because it increases your circle of sight.
What?
Yeah, the diameter of your circle of sight increases with elevation.
So when you look
The
up,
higher, the higher you
have a
go, the
cone?
larger the circle of sight.
Okay.
And the larger vantage point you can be seen from on the flat plane. It works both ways. The higher you go, the more you're able to be seen from. And that still despotizes and breaks down around 10 to, Jason was going to show what the record was. Was it close to 80 miles?
Yeah, 80 miles is really the record distance that we have for any ground-based observation. So if you're on the ground and you're filming something else that's part of Earth, we do have 80 miles being the record. That's from a rest stop on I-90 where you can see both Mount Adams and Mount Rainier. And if anybody can come up with something longer distance than that, please let us know. We'll research it, check it out. There's some fake flat earth disinformation out there that suggests being able to see 200 miles, 300 miles, and then people will go crazy and bring in Jay Tolan Media and say we can see 1,500 miles, and all this is
We can see
bullshit.
billions of miles. We can see stars.
No. No, you can't.
We have already established you can't
Yeah, we-
zoom anything in beyond the vanishing point.
Yeah, we could have gone.
Your own teammate stated that we cannot zoom the hull of the boat back in, right?
Remember, vanishing point gets longer the higher up it is, right? So if there's something directly above you, it doesn't matter how far away it is. Your vanishing point, it can be.
So then why is it that when we went up in our balloon-borne experiment on our last podcast on Sunday dealing with satellites and planes, why is it that we didn't see any of the stars when we got up into the sky?
I don't
When
know.
you go
Were
to a certain
blind?
elevation, why do the stars all disappear, T-Jump?
Wait, what?
After
what is this?
40,000
What is this?
feet,
the stars
there are no-
disappeared at night. When did this
There
happen?
When you go in a plane, stars disappear at 40,000, lower than 40,000 feet. They're completely gone. Go ahead and verify it. Test me, prove me right.
Do stars disappear when you are in a plane?
At nighttime, at a high elevation, they do. Jason's verified
Yeah,
it
I'm getting a
himself.
no. I'm getting a solid no from everything here. What?
No,
Why do you think that there were no stars in any of the pictures from the supposed moon landing, T-Jump?
What? Bad
There are no
quality
pictures
photos?
of the stars from the supposed moon landing.
Probably because bad quality photos didn't have the camera. Probably couldn't pick up the light. Most likely, I'm guessing
No, at
if
30
there's
at
if you're in a
30,000
plane, there's
feet
probably lights
at
in the plane,
night,
but-
if you are above the clouds, you're not going to see the stars, even if there's no clouds below you. But once you're into that range, and you can do the Google search. Why can't I see the stars?
Wait a
out the
minute.
airplane
I have
window?
pictures from a plane at 40,000 feet that I was in with stars. Like they don't.
That's
Because I
show
flew.
it. Show us.
I flew on a trip to where I was paid to be a speaker, and we went into a plane, and it went up. And
Or
we had
maybe you were
pictures, like it was
4,000
was
feet or
from my
something,
girlfriend's
right?
trip to France.
You might have been lower than what you think you were. You have to,
What?
because we've all experienced it. I've been up high and there was no stars. Jason's been up high and there's no stars. So you're not going to tell us that you're the only person in the realm that's ever captured stars from this elevation.
Well, I think
It's
like you
impossible.
guys are the only people who haven't. That's more likely the case.
That's retarded, bro. Do the Google search.
I can find it. I can find it. Oh, next question is, what is it? If we had a flat plane that was angled up into the sky and we drove a car up it, are they suggesting that the car would disappear from the bottom as it goes further away? Seems like that shouldn't be too hard of an experiment to perform.
That's impossible. It's one of the most retarded things. You want us to create a completely vertical road, the car would just slide
Not
down it.
perfectly. Oh my god! It doesn't matter if it's perfectly vertical. Any vertical direction up will work at any incline.
If you have a flat plane, you have a circle of sight that has a vanishing point on it, depending on the height of your observing either camera or eye position. So no matter what plane the flat plane is angled at, you will still lose the object depending on the distance to the vanishing point.
So that means the question was: if we built a big ramp and drove a car up it, would the vanishing point imply that it would disappear from the tires first? That was the question.
Jason, what do you think? I'll turn it to you.
I'm not even paying attention to that. I was just preparing to show everybody what the largest telephoto lens of all time. All right, you can look this up.
So
this
here's
is
I found the picture:
Canon.
meteor shower at 40,000 feet from plane. There you go. Stars.
You understand that in order to take pictures of the sky at night,
You have to be
it
fixed.
takes long exposure, right? It has a very long exposure. So if there's any movement whatsoever, it's just going to be a
Blur.
right?
No.
Yes.
No.
We filmed the stars,
Have you-
bro.
have you
We
ever
actually go out and do
taken any-
this.
No, it
photography
depends
of
on the camera you're
stars?
using. If you're using actually an
No,
expensive
have
camera,
you
that's
ever
not garbage,
filmed the
you don't
star
actually wanna do
trails?
that because
T-Jump, have you ever filmed the star trails or taken a picture of the night sky?
Yes, many
Were you
times.
stationary?
Any vibration, even too much wind, will end up in blurred.
Like literally, you're just
results.
wrong. Here is a picture from
No,
a
we're not
plane
wrong.
window of stars outside of a plane at 40,000 feet.
No, it's CGI. I've already gone through all the YouTube stuff.
That's crazy.
Yeah.
Listen, you cannot. If you can take a picture while walking through your backyard, take a
Answer the
picture
question.
of the
So
stars.
the question
and
was:
show me.
is if there's a ramp going up into the sky and there's a car driving up it, would the vanishing point imply that the car is going to disappear from the tires first?
Everything disappears from the bottom up at a distance. Yes.
So
correct.
your answer is yes, I think.
Yeah.
All right. Why are the legs reflected in the photo of the girl?
Because she was
Reflected.
beyond the vanishing point, and she was disappearing into the vanishing point. That's that glossy layer where you saw the haze or whatever. That is where the person disappears into. eventually, if they can go far enough away, they will completely disappear into that haze.
Okay. It says haze and humidity are causing refraction. That would be the answer that he gave.
Air conditioned space. It was we chose the location so that nobody could say that it was humidity and things like that.
Humidity exists in air conditioned spaces too. Heat, cold, temperature differences, cold falls, heat rises. Turing test. Thank you for the super chat. Thank you for the lulz, TJump. You're welcome. Could you please share the details of the flat Earth model, a maps perhaps from Turing test?
Yeah, we can, but you know what? That actually sounds like it would be best suited for our next conversation, where we actually go through the model that works.
Well, do you have like just a quick picture you can show people?
Sure.
And you are screen sharing again the OBS screen and all that, but it doesn't matter as long as people can see the evidence that you're bringing
I clicked
forth.
on the right one.
Oh, did you?
Yeah,
it's fine. I don't mind. We're not trying to hide anything. Are you trying to find the picture of the map?
Yeah, it's right here.
Okay, boom.
So I can actually even. It's too bad Mr. Sensible's not here, because this actually shows day traveling over the face of Earth. So this is a stereographic map that has 2 polar points, and the yellow lines are the tropics, the red's the equator, and what I have is circles of sight that show sunrise through sunset. And so if I hit play on this, is it at this section? So I actually put it into, here it is. Come
on. So they're
right,
asking, are they suggesting this is an accurate flat Earth map? This is it?
Yeah, and it's also your sphere Earth map too. It wraps to a ball. This is the same map you need.
Well, see, the thing is every single latitude and longitude.
So there's, just to clarify, there's 2 halves to like Antarctica at very different locations.
It's split. There's 2 polar locations, and Antarctica is split east and west. Have you ever seen a map of Antarctica where they split it east and west?
So I'd have to. There's no way I could walk from one of those to the other one.
Sure, you could.
No, absolutely. You got to watch the video. It's all explained in it.
Yeah, the easy way to explain it is we live in a continuous closed system. To answer the great science question, if there's dragons beyond the horizon, I just took the liberty of just helping George Smoot and the rest of science out. We actually do have definitive proof that we live inside of a contained, closed, continuous system.
So there's no way to get from the left side to the right side. So
you just simply walk across it.
Yeah.
What?
Fly, swim.
You can arbitrarily move the borderline anywhere on the map. It doesn't matter. It's a contained, continuous system in all directions.
So like you would, if you crossed the right side, you would teleport to the left side. Is that what you're saying?
There's no teleporting. Like I said, you can move the imaginary boundary. We've set the map up like this in a stylistic way that you can understand the land masses.
You've acted like you understand video games and computers, but now all of a sudden you're sounding confused.
Well, in a video game and computer, you teleport from one zone to the other zone. I don't understand.
Sure.
Like, so you're saying that
we're in a stereographic virtual reality.
There's no teleporting.
Bridge.
No Einstein-Rosenberg nonsense. We're in a closed, continuous system where you can move in any direction and come back upon the original starting point. But there is no else to go outwards outside of this realm, this map that we're showing. This is it. North to south, east to west, it's continuous. There's no looping, because when you get to this edge of the map, you're simply just moving to the next side of the map. Every kid that did a grade 3 studies that learned how things would navigate from one side of a flat map to the other understands this. You'd have to be brain dead to not understand the concept.
So if I have a flat piece of paper, right, and there's a left corner and a right corner, what mechanism teleports me from the left corner to the right corner if I walk off the edge? How does this work?
Stereographic virtual reality. Do you understand how video
computer
games
magic.
No.
What?
He said computer magic.
Do you understand the principle of how you go from one side of a map in a video game to another?
Yes.
Now, if you're in a
computer magic.
stereographic virtual reality, you understand. Good job.
Yes.
Excellent, TJump. You got it, bro. And the fact that we're able to model it and we put it in games like Atari, Asteroids was one of the first, helps prove the point. You don't have, you in your debate with conversation with Jason, you pointed out that some of your games are spherical. Yeah. And then you zoom in on a flat map that has a circle of sight that you can see. Most maps you have to engage into that other section of the map for the light to turn on. You understand all these concepts. I know you do.
I was just trying to understand. So you think that there's a computer teleportation system that loads?
No, you just made that nonsense up. I explained to you that it is a continuous closed system. So therefore there is nothing else than what you can see, but you can travel in any direction and come back upon your start point. Now, we haven't circumnavigated the Earth north to south, nor do we have any evidence of it. But east to west, yes, we have, including the sun and the moon and all the stars. They do that every night, depending on where you are in the realm.
All right. Super Squid Hunk asks, is there a way to calculate the vanishing point? How far away does something have to go before you start seeing the bottom disappear? Can they provide a calculation?
So it's something that you got to test because it's going to be dependent on the instrument that you're using. So whatever camera, whatever focal length, that's all going to play a part. So what you can do is just test things. You can measure out distances, see at what distance it starts to disappear for that tool. When it comes to the curve calculator, as far as how far we're supposed to be able to see it, it is relatively accurate from what I've been able to see that at the elevations, if you type in that you're 1,000 feet in the air, the distance to the horizon calculator will give you a pretty close approximation of what you're going to be able to actually go out and see and witness.
Because they had to back engineer what they called curvature with an actual observable evidence.
No, we're asking about your circle of vision number that's made up by you, and that
but it's not ours.
No,
just measurable.
No.
Using right off the internet.
This doesn't exist in round Earth models. This is your thing.
Distance,
so you're saying that
distance to the horizon calculator.
Well, no, because you're saying that things go up and they are also affected by this circle of vision.
Everything that goes up comes down.
Yeah.
I wasn't talking about gravity there. So you're saying this circle of vision thingy, when things go up into like straight up, like let's say a spaceship that could go into space or something. Let's hypothetically say there was such a thing. You're saying because of this circle of vision thingy that you think exists, the spaceship would disappear from the bottom up. Bottom of the
so now you're asking a hypothetical: if a spaceship was to take off and go straight up, it would actually be lost due to its totality of the way that it gets smaller. We can only see things from how far do you think you can see a school bus? How far can you see a school bus, TJump?
This is what the questions we're asking.
For like half a
mile.
mile.
Does the circle of totality thingy that you're talking about affect objects going up the same way they affect objects on the horizon, where they disappear from the bottom up? That's the car on the
They don't disappear from the bottom up. If an object was to fly directly above you and straight up, it would disappear due to the shrinkage of its totality and size. You can only see a school bus drive away so far without the so-called vanishing point in the way that we observe perspective. Your hypothetical is imagining that we could see forever when objects get a lot smaller as they move away from us. So even if
that's the question. That's the question is would you be able to see the object disappearing from the bottom up if it was going up?
No, absolutely not. You need a flat horizon and a plain Earth with an actual circle of sight vanishing point to actually measure what we actually measure in reality.
Right. That was the question. The question is why is there the vanishing point only at the horizon and not up?
It will go out of your circle of sight if it goes up too high too. Anybody that's let a high altitude balloon go up will know that it went out of their circle of sight. That's when they couldn't see it anymore, right? Going straight up.
And you're saying that thing will disappear from the bottom up as well?
No,
it'll diminish in totality to the point where it's just not visible anymore. The horizon is the obstructor, the bottom up. So something going away from you on ground, on water, right, that will disappear from the bottom up as you're going away. But something just straight above you will diminish in totality because there's no horizon to block it out.
Okay, so the horizon is the thing that causes things to disappear from the bottom up, and it doesn't apply to the sky stuff.
No, there's no horizon in the sky. It's a vast open expanse, as it says in Genesis.
That was the question. That was what the people were asking.
Yeah.
Okay.
Good.
I think that's it for the
question.
super chats. thank you guys for coming on. Appreciate the time. And
Yeah.
Thank
ready
you.
to close it out whenever you are.
All right,
Do you
sounds
guys have any
good.
super chats?
No,
We're
we
not-
don't do
we're-
that.
We're not monetized. We
Oh,
do all
gotcha.
this for free.
Gotcha.
Passion project.
Yep.
Cool. Well, thanks again. Let's do this again sometime. And
All
yeah,
right.
Mr. Sensible was talking about you chatting with Fight the Flat Earth. That would be interesting for me to host as well. That would be fun.
Two grows. Two grows.
Well, he was trying to say, Mr. Sensible, Jason, that Fight the Flat Earth, maybe he's not like that anymore, that he actually, he'll
okay.
treat us with respect, he was saying. So I don't know. We'll talk. We'll see what goes on. Maybe if by popular demand, right? Maybe
Yeah.
I'll sit
I
out the
can-
next one. I feel like I did a lot of talking, so I'm good.
Well, I can moderate. I can moderate and be fair.
I can self-moderate. We just yeah.
Well, no. So I'd be moderating him. That's your concern is him, right? So I would be
Yeah.
happy to moderate and make sure you both get equal time.
It'll be
Yeah,
great.
as long as we're not under somebody else's thumb. If we've got the live stream, yeah, anybody can act ridiculous, and we can just let them go if they can't behave, right?
Sure.
Yeah. But thank you. And
Yep.
so maybe we'll have the opportunity to go through the stereographic virtual reality explained. So far today, what we've done is we've debunked heliocentrism. We've shown people their small circle of sight, and that the sun, moon, and stars are actually operating within your circle of sight. And it's been great. Thank you, TJump.
Yeah, absolutely. I think the best evidence today was presented by Mr. Sensible and his camera that he actually went up in 35,000 feet.
The one he
That
didn't
was-
know which camera it was. Yeah, good luck with that.
Yeah, well, the camera. Like, I don't think you have to memorize literally the camera name. for it to be
Okay,
evidence.
move on. Thank you for
All
having
right.
me.
Goodbye,
right.
everybody.